starting now or? Thank you. So let's see. Yeah, I was a bit sorry. I was a bit nervous. So let me try something. Hold on. Where's the? So I was trying to do a talk on this and give me conference introduction speech for my talk. And let's see. Okay. Let's see what ChatGPT is trying to give me for my for me to. Okay, let me try this. Hold on. Wait. Sorry. Let me change a bit prompt and let's see what we will have here. Okay, so well, ladies and gentlemen, enchanters of code and weavers of the World Wide Web, welcome to a journey where the boundary between conceivable and the magical is not just crossed, but obliterated. I'm thrilled to guide you through the enchanting realms of SvelteKit and the magic of progressive enhancements. In our time together, we'll explore the alchemy of SvelteKit, a framework that transforms the complex into compellingly simple, conjuring up web applications that are not only lightning fast, but also bewitchingly smooth to interact with. We'll dive into the arcane art of progressive enhancements, unveiling how these practices can elevate our user experiences from the mundane to the magical, ensuring accessibility and delight under any circumstances. Prepare to be spellbound as we unravel the secrets of creating web experiences so fluid and responsive. They've seen conjured from the very essence of magic itself. So let us embark on this captivating expedition together and discover how to weave our own spells in the digital ether with SvelteKit and progressive enhancements. Go! Well, that's weird. Anyway, I guess I'm more comfortable with just hello everyone. Good morning and welcome to my speech. Let me introduce myself. I'm Li Hao. This is my Chinese name. Well, family name comes first, so that's Tan. And you can call me Li Hao as my given name. I'm a front-end developer at Shopee, a leading e-commerce platform in Southeast Asia. I'm based in Singapore. It took me 14 hours of flights to come here. And I'm born and raised in Malaysia in the 19th century. Well, my hometown was part of the British Straits settlements under the British East India Company's control. But fast forward today, here I am speaking on a stage in a place where once navigated by my grandparents, colonizers, talking about the magics and the web. You know, how interesting of that. Well, anyway, don't take this picture as is because it's drawn by Dali. Okay, it got the general shape all right, but all the labels, everything is wrong. So if you're interested about Southeast Asia's histories and cultures, you can always we can always talk about it. Well, I grew up in this lovely town called Bukit Mertajam, and it's a great place with amazing food, traditional cultures. And outside of work, I do a bit of open source. I'm a Svelte maintainer, though I was mostly active during the COVID period. Well, now I mainly talk about Svelte and make contents about Svelte on YouTube. And I recently wrote a book about Svelte. It's called Real World Svelte. And I have a few free copies from the publisher. So if you find me later, I'm more than happy to give it out after the talk. Just come on in. Yeah, you just right at the nice moment, right? So, yes.
any schedule? No.
For people who are watching live streams, we have more people come in from the keynotes, and we are just going into it. Huh? But they missed the intro. It's okay. Well. I generate the logos. Most of the logos are also generated from ChatGPT. I got most of my slides prepared from ChatGPT. It's been very helpful for me in preparing this talk. So, for those who just came in, we did some intro, right? So I guess I will just stick at, no. Oh, yeah, I guess I will introduce myself again. I'm Li Hao. I'm a front-end developer at Shopee. Tan is my family name. It's like Chinese name. Family name comes first. Tan is my family name, and you can call me Li Hao. I'm a front-end developer at Shopee, a leading e-commerce platform in Southeast Asia, which is based in Singapore. So it took me 14 hours of flight to get here. And well, this is my town that I grew up in. And outside of work, I do a bit of open source, and I'm a Svelte maintainer. And I was mostly active during the COVID pandemic period, and now I mainly talk about Svelte and making content on YouTube. So, and I recently wrote a book about Svelte. It's called Real World Svelte. I have a few copies from the publisher and some discounts if you order online. You can find me later, and I'm more than happy to give it out to you guys. So, progressive enhancements. What is it? Well, most of the time when I don't understand something, I ask ChatGPT, right? That's what most of us, that's most of what I'm doing right now. Well, it says that progressive enhancements is a web design strategy that focuses on the most fundamental layer of a website that can work on the widest range of devices and browsers, and then add more advanced features and enhancements in layers. This approach allows our website to be accessible to everyone, regardless of their technology's capability. Progressive enhancements often get tied to the idea of HTML first, and its proponents as anti-JavaScript. This perspective might come from advisors like emphasize starting with HTML and to ensure your website functions without JavaScript before adding CSS and JavaScript layers, which is not wrong. And my own take on progressive enhancements is to build your site to work with as few dependencies as possible, and feel free to make it as engaging and interactive as you wish. Why? Well, the less things you depend on, the more likely your site works with the most number of users. You may have users that have devices with only older browsers, so you can't depend on the latest JavaScript syntaxes or even JavaScript. You may have users that cares about security and privacy, who disable JavaScripts to avoid malicious JavaScripts or tracking scripts. You may have users with not so great internet connection, which is me. Whenever I navigate through an underground tunnel on public transport sites heavy on JavaScript, requiring significant data to display content. So I only see a white screen, and I wait for very long to see the actual things, right? It just doesn't load for me. Well, so I screenshot this, which it resonates with me. It says all your users are non-JavaScript users while they are downloading your JavaScript, right? So if you need JavaScript to see something, and then so most of them see a blank space. So does it mean we don't or no JavaScript? I would say like the resistance to JavaScript stems from client-side based JavaScript frameworks, where you need to load a ton of JavaScripts on your user device. You need to run them in order to see your content. However, most modern frameworks nowadays support server-side rendering. Many frameworks today allows you to run JavaScript on the server to dynamically generate HTML. Right? So you still write JavaScript, it runs on the server now. This means your user can see your content on the first request, which then becomes more enhanced and interactive as you load additional JavaScript that runs in the browser. Many frameworks or meta frameworks attempts to make it easy for you to develop your web applications this way. So, and today, my focus is on Svelte and SvelteKit and see how it helps with progressive enhancements. When you visit web app, the most common interactions fall into two categories. It's either you browse around, navigate through the content, or you transact and perform specific actions on your application. To navigate around, we create links using the anchor tag, which is one of the most fundamental elements in HTML. Right? I don't think there is any browser that does not support this. So you can specify where this link goes to, and you can use it to navigate across different pages. Right? As an example, you can see here we have a list of images. Each image is wrapped with an anchor tag. So when you click on them, it navigates to an image detail page. Right? To build a web app like this in a SvelteKit project, we create routes using the plus-page.svelte components. So as you can see here, we have two of that components in my source routes folder. So we have two routes, two plus-page.svelte components. So the first one is for the routes, which is to see the home page, see a list of images, where we have a list of images and wrap them with the anchor tag. And the second is with the image detail page, where you can see the image descriptions and navigate between them. So to navigate between them, right, we are using this anchor tag. In SvelteKit, you don't need any special link components. You just need this, the anchor tag. So what's so special about this, right? Well, in this talk, I'm going to share how SvelteKit progressively enhance your routing experience. How does it make this anchor tag special, or how is it useful, and how is it progressively enhanced? So there are three features they're going to talk about what SvelteKit provides. First of all, when you this anchor tag, it's no longer just like how you have it in your normal HTML applications, where you click and then the browser navigates to a new page where it loads everything all at once. When SvelteKit is being loaded in your application, what happens is that now it will do some magic behind, and it will transform your anchor tag to do soft navigation, which means you will still feel the same as navigating around. There's no difference. What your user will see is the same, but like your URL changes, you have a new history, you see the page updates, but the only difference is that the only parts that will change, that needed to be changed, will change. Right? So if you have layouts with navigation bar, you have a sidebar, those things will stay there. All the states will be preserved because with SvelteKit, we are not throwing everything away and recreating them again as you navigate to a new page. Only the content that is loaded will change. Only the new code for the section that the new page is needed will be loaded, and data or common code that needs for that's common between both pages will not be fetched again. Secondly, SvelteKit provides navigation hooks, allows you to enhance your user experience as you navigate between the pages. Right? For example, you can create like a progress bar that you see on top of the page. That can be done easily with the before navigation and after navigation hooks. Here, we can use it to change the value of the show progress states, which is used to conditionally show or hide the progress bar. Right? You can do a lot of things besides that. Well, thirdly, SvelteKit also provides shallow routing. So what is shallow routing? See, in this example, as you click on the image, it is, instead of going to a new page, we actually stays on the same page. But the destination page, the page that you're going to, opens up within the pop-up. Right? Sometimes you want to achieve this user experience because you want the user to feel that it stays on the same page. But actually, you are navigating to somewhere else. So what we can do is we can rely on this feature called shallow routing, which is instead of letting SvelteKit to handle the default routing behavior, with shallow routing, you can take back the control and decides how to navigate around, right? So you use this API called the push states, which I'm going to show you how it's done in the code. Firstly, you need to modify the default behavior of the anchor tag. You add an on-click listener. So when you click on the link, this is where it's being handled. And you call the events.prevent defaults to prevent the default behavior of the link. So with this now, when you click on the link, nothing will happen because you have prevented the default behavior. And then you call push states to update the URL and add a new entry to the history stack. So at this point, the URL and history has changed, but the page content has not changed because you have prevented the default behavior of SvelteKit. To differentiate between new history entry with a normal click and actual navigation, and the differentiate between what it was previously and right now with shallow routing, we can add more data to our history states. Right? So now when you navigate to a new URL, you can actually add states to it, like so. Right? And this states is also part of the page store that provides from SvelteKit, which you can subscribe to, and you can use it to dynamically show content based on the page store. So here I have the modal elements wrapping around an image. So the modal here is showing only when there is image in the history states. And this is how we dynamically show the modal with the selected image when we click on the link. So since a route plus page.svelte is a component as well, it's just like any other ordinary Svelte component. You can import it, right? So this is the components that we use to render the destination page. And you can use it in your code as well, like this. But since the page component usually have data that comes from the load function from SvelteKit, to get the return value of the load function, you can use the preload data to get more data from SvelteKit and use it to pass it to your states. Right? So SvelteKit will handle this for you, whether the load function should be run on the client side or run on the server, or whether it should be run on both server or client. SvelteKit will figure that out and will get you the data you need from the load function and pass it to this. So you pass this data to history states, and you can pass it to the image detail page component. And so with those code changes, there you have it. The best thing about doing it this way is that when you refresh or share this URL, it's not just a modal with a local state. It's actually navigating a new page. So this URL you can share to anyone. It can go directly to how it should be when you without JavaScript or with the page that they should be opening. Right? So opening a modal from the home page when clicking the link is like an enhanced viewing experience rather than going directly to navigate to that page. So in summary, we've seen 3 different features SvelteKit provides to progressively enhance your routing experience. We have soft navigation hooks, shallow routing. There's much more, but we just covered 3 today. So the next common interactions on a web app is to transact and perform actions, like making a purchase, switching languages, submitting a comment, hitting a like button. And all these actions relies on one fundamental element on the web, which is the form elements. Right? The form elements goes way back. It's the default elements for submitting data and performing actions before we even have asynchronous JavaScript and XML HTTP requests. So instead of calling APIs using the fetch functions like this, you can change it to a form element, and it behaves the same as well. Right? And in both cases, when you hit the buttons, it will send a post request to like post with a HTTP post request with like the ID equals to 123 as the form data, except that the previous example, which is this one, you can't really make fetch calls. Sorry, whoa, what did I just do? Okay, sorry. So except that the previous example where you make the fetch calls, you will actually make asynchronous network requests, but you stay on the same page, right? So when the response returns, you need additional code to handle that. You need to figure it out how to handle. You need JavaScript to figure out how to handle the response, and you also need JavaScript to figure out how to update the page content so it stays in sync with the data you just updated. But in this example, with the form elements, once you hit the button, right, once you hit submit, the browser will actually navigate to this like post page with post requests. It's all done by the browser, and it's up to you what contents to return on that page, right? If you want to stay on the same page, when you go there on your server, it can redirect it back to after it processes the data, it can redirect back to this current page. And as you load this current page, in the server, when you render this page, you can fetch data from the updated data, and you can, you can load the page with the updated content, and all of this is done by JavaScript on the server. You don't need to handle it on the browser through JavaScript. See, in this example, as I click on the like button, the browser navigates to this page with post requests, and it redirects back to the home page. And as we load that page with the updated content, you can see the like button is updated and the count is increased. And all these interactions is done between the browser and your SvelteKit server based on only the HTML it receives. So think about it, you get all of this for free with just HTML. Right? With JavaScript, without JavaScript, on the browser, it still works. So if you have a form element that performs actions and submitting data, then the user can immediately perform the action with the HTML loaded. You don't have to wait for all your JavaScript to be fully loaded. You can already perform actions. And literally, if you think hard enough, anything can be a form. Right? Like this one, a model to post a tweet can be a form. Or this one, choosing between a Kindle paperback and buy now with one click, this can be a form. Or this one, like a search bar. I mean, this can be a form as well. So like this one, like a Wordle game where you see a keyboard of buttons, this can be a form. You know, you can submit different values to the form, to the same form, where the button carries the key and carries the value of what the button is showing. Right? So you can just have many forms and it will work. So you think about the UIs you've been creating, those that perform actions and submit data. Are you able to turn them into a form? Well, in a form, if you don't specify actions, So let's talk about forms and SvelteKit, right? What are the things that SvelteKit provides for a form? Because all you see just now are the basic things about forms that has existed way before SvelteKit. It's the default way of submitting data. And I'm going to cover a few more basic grounds about how you use a form, right? In forms, if you don't specify actions, it submits to the current page, right? Meaning, based on the form methods, the page will, in this example, the page reloads with a post request, right? So, so this is more common for most interactions when you submit, you want to stay on the same page when you submit a form. And eventually, if you want to redirect back to the same page, submitting the form to the same path saves you from creating another API path, which you will eventually redirect back. Well, so this is SvelteKit. Of course, it provides a simple way of handling form posts on the server side. It's called a form actions. After the form is processed, the load function of the page is called to get the latest data to load the page. So you can have this actions that process this form data, and then you load which runs on the server side, and then you can load the page with the updated data. So sometimes you have more than one forms on the same page. How do you differentiate between them? Well, this is SvelteKit. Of course, it has features that allows you to submit the different forms to the same URL path. You can see the form actions submitting to the same current path, but we use these weird query parameters that starts with a slash and follow with a name. And so these are called the named actions. Well, this is SvelteKit. Of course, you can have as many named actions as you want. Just remember that the default is reserved for the default form actions. If you want to have more, then you have all the different form named actions. Well, this is just a normal form elements following web standards. Of course, it supports like custom form action attributes in the submit buttons. This way, you can submit to a different named actions within the same form. Right? So you can have a form with 2 buttons, upvotes and downvotes, but they submit to different form actions, to different named actions. Form works natively as it is. It works, but we are JavaScript developers. Of course, we're going to enhance this user experience with JavaScript. So now with forms, every time you perform actions, it refreshes the whole page. Well, that's not great, right? So this is SvelteKit. Of course, it's going to make it easy to enhance the form. You just add this enhance action onto the form elements, and you're done. Well, this is SvelteKit. Of course, it's that easy. So what does this enhance action do? Well, it does what you expect. It updates the form property. It updates the form. It updates the page store accordingly. It resets the form. It resets the focus. It invalidates all the data. So the load function will call again. It forms. If your forms redirects, it goes to the next destination. If your forms got error, it render the nearest error boundary. It does all this to make sure that basically with or without adding this enhance, you get the same form submission behavior, right? Except that now you don't get a full page reload. Only the page content that needs update will update accordingly. Now the user experience is the same as calling fetch, but now as a developer, you don't need to worry about state management. You don't need to handle how to handle the updates of the data or the states. All that's taken care for you. So that's it. Forms is that straightforward. And once you see every interactions as forms, you can turn all of them into a form. So in summary, we've seen how you can enhance the browsing experience with anchor tags and navigation hooks and shallow routings. And with forms, we've seen how you can use forms to perform any transactions. And with enhance, you can submit the form without a full page reload. So that's it. Thank you. This is where you can find me online. On the left is my website, and on the right is a QR code for discounts for my books. Right? So instead of manually typing these URLs in the browser, you can send this QR code, which is a more progressively enhanced experience. So thank you, everyone. Thank you very much for the interesting info. Next one coming up is Sheila. Wait, this one? You can hand
All right, I think we are ready to start.
So this is the mic for here, and this is the mic for the street.
Yes.
Okay, so I cannot walk. I need to be here.
I mean, if they.
So I need to scream. Awesome.
So welcome once again to those of you who is in this room for the first time. We have Attila with us today, and he's going to talk about SolidStart Reactivity. Please, big welcome.
So, thank you everyone for being here. So yeah, let's start talking a little bit about reactivity. But before, who the heck am I? So I'm a developer relations engineer. I work at a place called Crab Nebula. More on that later. People are very involved in the Tauri framework. If you haven't heard about Tauri, you will in a second. The second part is I'm also a member of the SolidJS developer experience team, which means I'm maybe a little bit biased about the things I'm going to talk about, but just a little bit. And I'm also a Google developer expert for web technologies, but yeah. And because naming things are very hard, I made some shortcuts. I'm in every one of these social media. You just put attila.io and pick whatever you want. And if you message me, I'm going to reply. I'm always up for a chat. And yeah, that's who am I. So because of my work at Crab Nebula, I need to test a bunch of frameworks. And because of what I do at SolidJS, I also need to have a look at the APIs and stuff like that and think about rendering performance and so on. So I am very convinced fine-grained reactivity is a great thing. And so, yeah, so basically you just heard it. So someone said fine-grained reactivity is going to help you ship better apps. And the first thing, before going refactoring all your stuff, the first thing you need to do is ask one question. Why? Like, don't take any word for granted. So does anybody know like any reason why fine-grained reactivity could help you ship better apps? Any like single word? Anybody want to shout something? Yeah, performance. Thanks, Stages. I set it up and he helped me. So the thing is, a lot of people talk about performance. A lot of people, when we talk about fine-grained reactivity, you immediately jump into performance, and that's a little bit, hi, Nathaniel, cool, nice to see you here. So the nice thing is, we talk a lot about performance when it comes to fine-grained reactivity, but to me, that's a very nice side effect of fine-grained reactivity when dealing with apps. The real reason to me is on the mental model. And to that, we need to very briefly talk about different ways of handling data in your apps, or data, I guess. But anyways, you have the pull way, so you can pull the data. You have the push way, which the provider is going to push data into your app. And you have another method, which would be push and pull. So let's talk a little bit about each one of them. First with the pull. So essentially, you have the provider of the data and the consumer of the data, which is the data part in this part in green, and the component that's going to take it. So the component needs to, every time it needs to fetch for updates any single time. So if they're re-rendering or something like that, they go, oh, do you have updates? No. Do you have updates? No. Do you have updates? Yeah, I do actually, take it. So this is, as you can imagine, it's a pretty inefficient method, because every now and then you're basically doing some manual pull, I would say, and it does some consequence in terms of the data is not able to let your engine know it's updating. So basically, you need to do a lot of extra work to accommodate this. The second way is the push version, where a data becomes available as soon as the provider has it. So the provider just shoves it into your component, and that can cause some other issues in terms of, like, if you heard about back pressure, where at some point, the data has no way of knowing if your app is ready to take the update. So it just keeps sending updates one after another. So you probably have heard about words like debouncing or throttling and stuff like that to handle this kind of back pressure. So it's a way of more imperative handling this. But when it comes to observers and this kind of stuff, you have no way of handling that. So this can cause some issues. This can cause either your data to your component side to just give up receiving the updates, and then you happen to have stale data somewhere, and state tearing because one component was able to update, the other wasn't. And you might have other more serious issues if you don't care about, if you don't look for it, which is potentially even crashing your app or something like that. And then you have the push and pull method, which the data signals to your, see what I did there? I updated. And then everybody that depends on the data gets the notification that it got updated and say, okay, please send me. And then you can get it. So this kind of prevents the back pressure issue. And in the same way, in the same thing, it also prevents you for needing to check everything and make sure that your app is up to date on the pull version. You need to basically re-render the whole thing. You need to destroy the current state and build it up again because you don't really know which components are using which pieces of the data. So to make this whole analogy a little bit more clear, if you haven't figured out, pull state is what use state does, and like, for example, use state in React, I would say. So essentially all the virtual, every time you have some virtual DOM or some block DOM or this kind of other stuff, when you're not handling with any kind of subscription model, you have a pull version. Push data would be more like the observer pattern, more of like what, both of them are observer patterns, the push and pull, but it's more on the observer side, like RxJS or things like that. And then push and pull is what we do with signals. So I use create signal there because I'm SolidJS guy. There's some Svelte people here. They would use runes and this kind of stuff. So Vue people would use refs, but essentially they're the same pattern. So this means if you're more of a React developer, you're used to like having the component smushing together rendering and data. With signals, you kind of split them apart again. So your data is responsible for itself, and you don't re-render the stuff over and over again. That's the mental model that shifts on that, which can lead you to have more performant apps because mutating stuff is way faster than tearing the whole thing apart and starting again, as you might imagine. So just a little history look back. When SolidJS came out, the creator of SolidJS said, okay, signals are a pretty great thing. Like some other frameworks try to do it, but they lack a little bit of the X here and there, but I really think we should have a framework built around signals for that mental model. And there were already some frameworks experimenting with that. Vue even had their own implementation of signals at the point, but the rendering model was a little bit more coarse, was not that fine. So if you fall out of the reactivity, it would do a whole update to make things more resilient. And fast forward a few years, what happened is that all the other frameworks realized, oh, that actually saves us a lot of hassle in terms of explaining how our rendering method works, in terms of helping our users actually ship better apps and more performant from the get-go, because that's what frameworks are all about. Like, frameworks are supposed to make your life easier in shipping with a higher quality standard than if you do it by yourself. So to summarize, what happened is that somebody said, yeah, I can use Memo whenever I want, and said, yeah, I actually have signals. And you see where this is going, essentially. And to point out like the reactivity part of Solid, what we do is, if you look at this from a reactive, there's a lot of comparisons to React because it's the most like common framework. Who here is a React developer or worked with React more? Cool. So yeah, I'm not that wrong. Awesome. So if you look on the first glance, and if you squint your eyes a little bit, it actually looks like a React component, right? But we have this create signal there, and fundamentally, though you're building your component in the very same way because you're also using a certain flavor of JSX, things behave differently. So like if we render this button in a screen and we click on this button, what would happen in a React thing is that the whole button goes away and then it comes back with the new state. With Solid or with fine-grained reactivity, what happens is once you click on it, there's one piece that updates actually, which is just that little function call. So your DOM node doesn't go anywhere, it just gets mutated. It updates the DOM node only on the value side, only the text node. which leads to the whole like thing that, oh my God, signals are so performant, yada, yada, I'm going to use that to make my apps faster. That's the thing. So you don't actually need to prevent re-renderings because they don't exist. So yeah, never using memo again, right? That's the point. Well, there are situations to use memo. Memo is not like a bad pattern. The problem is when you use memo to fix engineering problem, where memo is a whole different solution, is to prevent computation that you don't want to happen again. So I have this little very contrived example where if you have, like in this case, we have in the super count, we have what we call a derived signal, which is a signal that is built from a value of a previous signal. And this is basically having a multiplier there. But the way I'm doing, which some of you might be cringing already because it's not a great way because I'm recalculating the multiplier every single time I call that function. So you probably already noticed I don't want to do that because that's gonna mean that every time I call this function, I'm gonna change the actual value. So this is a very contrived example, but it's supposed to exemplify why would you use a memo. So let's have a look at this little, where's my mouse? Yeah. So, yeah, so we have the docs. And so I just put the same component I had in the screen. Like I changed a little bit just to make it a little bit easier to read. Let's zoom in a little bit because you don't need to care about the return type on the JSX and whatever. What you need to do, what I want you to look at is that I have the super count being rendered here in the bullet point, and I have my actual count. So for the same value of the count, I have multiple different ones. And every time I change the count, I need to call the function again because super count is actually subscribed to the value of count. So when count changes, I need to recalculate super count. And when I'm recalculating super count, I actually have the multiplier being calculated again. So this would be a decent way to having a memo here, because if I do the memo, it means that I'm going to recalculate the multiplier only once every time the count changes, because if count didn't change, I don't need to run anything again. So why I say this is a contrived example, because there's actually a better, a different solution that I could do, which is a variable. Because this doesn't run again. If I just store this as a reference in a variable, I'm not going to calculate any time anymore. So that's why I said this is a contrived example. In a real world, you would have something very much more complex in a derived state that would require a memo, but that's the actual use case for a memo. So if you have something that's heavy for you to compute and you want to make sure it's only going to run once, that's why you use a memo. It's not to prevent like small re-renderings or stuff like that. And yeah, so that's the whole point. But yeah, that's all nice, this pseudocode. Every time it's nicer, it makes things look easy, and then you go try it out. But your state doesn't look like a Boolean all the time, right? It's not like a simple count. You actually have complex types. So let's take these complex types and shove it in a signal like this. So you have something like a list of users, and you have accumulator to count the number of users you have, and so on. So how do we do that? How do we fine-grain reactivity that? Ideally, you would want something like this, right? So for every new thing, you get a new signal, and then you can update one by one. But can you imagine writing that? So that's why we have stores. So stores are basically create an object proxy and do that under the hood for you. So what we have here now is actually all the values inside this store are their own signal. So you can actually do everything one by one. And if you update only one, you're going to update only that little piece that changes. You don't recreate the whole object as you would with a signal. So yeah, and that's the signature. And yeah, but then, okay, how do you go with deep nesting in this case? If we have something like an array up right there inside an object or something like that, how do you update that? Because then you need to, how you do with that? So for that, we have something called produce, which is a helper that's part of the solid core. And then you can have this mutate syntax, and that's going to handle the whole fine-grained reactivity update, so you can just cascade down everything you want. So in this case, it will just update granularly what you want. And that's also good, but what about the other way around? What if I have an API that's going to give me the whole object and I don't really control the object, and then I need to tear the whole thing up again? So yeah, you could tear up the whole thing again and let the whole value update every single place. But let's say, for example, I have this weird to-do app that I actually want to look at my past to-dos, like grocery store, and I want to buy the same stuff I bought last week for some reason. So for that, we have something called reconcile. What reconcile is doing is going to have a shallow, it's going to do a shallow comparison to each one of the keys inside your complex object or type, like object or array, and it's going to shallow merge every single one of them. So that's going to guarantee you in this one-liner that if you have like a big update and you really don't know what changed or not, you call reconcile and Solid's going to figure it out for you. So to recap, fine-grained reactivity is about surgical changes instead of re-rendering. So that's the whole point that leads up to us skipping the whole beat and saying, oh, that's great performance. But actually, there's a whole mental model where you're only going to change what you wanted to change. You're only going to re-render what actually changed. You're not going to terraform your whole app just because you changed the Boolean. But that's for re-rendering UIs. So, but everybody now has a cool like isomorphic framework. They're all full stack developers. We're all going like blurring the lines between backend and frontend. And that's why Solid built a meta framework called SolidStart. And it's now in RC, which means in a few weeks it's going to be considered stable. What we're doing now is like testing, doing small bug fixes. We're having conversations like what should be the prefix for environment variables or stuff like that. The APIs are stable enough. But what the heck does a release candidate actually means? So just to make sure we all have the same understanding, when shipping an app, you have the alpha release, which means you're still working on the APIs, you're finding out use case, you're finding out what your users actually need, making sure everything works. So this is like very unstable territory. You go there as a tester, you go there as somebody that's interested to help, and you can use that. Once that's done, we go to beta, which means, okay, we found a model that we think works for our project, and we want people there can actually afford to test it and make sure it works the way we expect it does. And then we get to RC, which means we tested like thoroughly already, but we're lacking documentation, and we might have a few quirks here and there if you have a less traditional use case. And that's the stage we are right now. And then once we fix the small bug fixes, but most importantly, when we're confident we can onboard people successfully, then we go into a stable release. And talking about stability and the shape of this framework, SolidStart is actually very, very meta in terms of a proper meta framework, because Start itself is a very small package, but then it just puts together a lot of different packages, which means that we have our backend built with the same infrastructure that Nuxt has and Analog has. So this means that from the get-go, even when we were still beta, you could, for example, ship SolidStart to Nuxt hubs, for example, because we are all built with Nitro, which is an agnostic solution. Our server runtime is that, and all these other frameworks use. So this means that though Solid is a smaller community than a lot of frameworks, if you have an issue on the backend, you can actually piggyback on the other ones. So you can actually look at solutions that other frameworks are already doing, and you can use that. So we have this package called Vinci that was actually made by one of our core members that encapsulates Vite and Nitro to make sure we can split the bundle between server and client side, and we can have a proper runtime that has already been beta tested and has been in production even before we ship SolidStart. Then you have the serializer, which is a beast. Like it's something we're going to talk a bit later that's going to handle all your data modeling between the front end and the back end, serializing, like crossing the network boundary and reaching your user. This is like very complicated, and this is why we had to create this package that's tailored for SolidStart. We look at a lot of other frameworks. We took a lot from SvelteKit, for example. They have a great serializer as well. But in the end, for what we wanted to accomplish in SolidStart, we had to create our own. So another core member built this whole separated package. So any other framework that wants to use that in the end can do it. We have router, which is completely agnostic. You can bring your own router to the story. At this moment, unfortunately, the only router that has all the integrations required to have a SolidStart running is the Solid router. But Vinci allows you to very easily tweak and switch if that's the case. And then you have Solid in the very end of the thing, doing the whole UI rendering stuff. Okay, and that's all great, but that's way too technical. Let's talk about the features we have and what makes it different. The most important thing, and the thing that we went completely on removing, is request waterfalls, because that's what actually makes apps feel terrible, because you have chain requests, and then the request number 2 can only start when request number 1 finishes and actually arrives and parses and etc. So we abolished them. It's really hard to make request waterfalls in SolidStart, actually in Solid Router itself. And then because we have resource fetching in parallel by default, we can have something like, this is actually a real use case app. I wanted to show you this first because you see, if you're a React developer, you're used to this whole nesting provider stuff. We have the same problem, same pains. But what I actually want to show you is this. What I want to show you is that we can wrap our whole app into a suspense. So every route navigation is by default. When you're in the client side, post-hydration, everything is soft navigation, and you can have an intermediate state between routes as easy as that. So in this case, you have the root, and inside the root, all your file system routes are in this props children. And you can have like this pending state or whatever you want, which allow you to control the preloading method, which allow you to control when resources are going to be fetched and when your routes are going to actually load. Talking about data loading, we have this thing, which is the create async, which is how you use data from a loading method in this. So you can have something like this if you don't want to show your app. If you don't want to actually show your component before the data arrives, you can have something like this, and then you make sure that Solid is only going to render that once the data arrives. Other than that, this actually is where you protect your route if you want. So we protect data, not routes, in a SolidStart app. You can also do the defer stream, like if you're doing something that's very SEO intensive and you want to make sure the data is there before anything starts rendering, you can say to SolidStart, okay, just wait. I know what I'm doing. I don't want you to be as fast as possible. I actually want you to be as consistent as possible. Talking about preloading, you can actually just export a route like this and say, okay, so I want actually SolidStart. Every time you hover my link, I want you to actually start preloading stuff. So you fire the request before I actually navigate. So that means that even though you do all this whole shebang of not rendering anything before data arrives, chances are, by the moment your browser reaches the part about rendering that component, the data is already there anyway. And talking about protecting stuff and caching and deduplicating and performance like that, we have this helper method, which is cache. And you can define that the data loading and the data fetching is only going to happen on server side just by using a directive like this. And Vinci is going to take care of everything. It's going to make sure this never lands in your client bundle and so on. And the caching method is to deduplicate requests. So you've heard about like other frameworks that changed the prototyping fetch and stuff like that. And we saw that most people didn't like that. So our solution is actually exporting a cache method. And if you pass like a string key, you're actually helping SolidStart understanding that this request has this unique key. And then every time this key tries to go out of SolidStart to fetch something, we see if there's already something in flight. And that's why we deduplicate requests, but we also deduplicate resources, which to the best of my knowledge, we're the only ones kind of doing that. So the way it happens is you have this API and you have like 3 server functions that are actually sending the same request. So this hits the cache, which means you're only going to get 1 request going out of your API and 1 request coming in. Once that happens, it reaches a serialization, the serialization part. And that serialization is actually gonna make sure, is gonna make sure that the request, the resource that's being serialized is gonna be stored on this, for the lack of a better term, global store. That's gonna make sure that that resource that already exists never gets serialized twice. So even if you have different requests that's coming back with the same resource, you're serializing only once. And then we go to the RPC layer, which is the request, the procedure call, and then we reach your user. So we also have server actions, which is essentially very, very, very similar to what the server function is, but in this case, it's a nice synthetic sugar to deal with forms and handle the form submission. So it's pretty similar to what other frameworks do, like Remix, was, I think, the first one doing it. And you can actually throw redirects, which leads to the one that I think is the most interesting feature of SolidStart, which, so here you have an action that happens only on the server. And if you're returning a redirect or throwing a redirect from a server action, so let's say you have a login feature and the user didn't fail to authenticate or something, or actually authenticated, and you're sending them to the user dashboard, what happens is the same request that is going to authenticate your stuff is actually returning the data from the next page. So in this case, my login page goes to check if my user can authenticate, and when it comes back, it's already coming back with the list that I want to show. So you return a new page with the data of the page that you want to re-render. So you're saving possibly 2 round trips, but at least possibly 3 round trips, but at least 2 by doing that, because every time you're redirecting, you're already coming out with the data. That's why we call it single flight. And then besides the single flight and returning things, you have complete control of like revalidation, reload, caching. You can the whole point is to give you nice defaults, but being completely unbiased on how you're going to use the app. So you can at any moment remove anything of our settings, or even like the whole router, as I said before. If you want to know more, we have the docs that Daniel with me and Sarah are trying to get everything up to speed to leave RC as soon as possible. So you actually could take your feedback on anything there, and if we fail to onboard you on anything, let us know. We're always on Discord and stuff like that. So quick recap, if you're doing front-end, you want to find reactivity, I recommend you Solid. For full stack, you can use SolidStart. What about native? And when I say native, I mean like any other operating system. If you want to have like an installed packaged app experience with Linux, Windows, Mac OS or iOS or Android, my recommendation, and again, I'm biased because, as I said, I work at Crab Nebula. We are the ones behind Tauri. You can mix them both and have a hybrid app, and that's actually what I do at work. So just for the ones, who's familiar with Tauri, by the way? My friends? Yeah? Awesome, cool. So Tauri is a framework to building hybrid apps, so it uses Rust as the backend layer, so the window management, the native window part, and then it has a component that brings in the native web view from the system you're at, which means you can use any web technologies. You can use jQuery if you want. You can also use Svelte. You can use any framework you want. It's literally bring your own stuff. So at work, we actually have a web app that's a single-page application built on Solid. And inside this monorepo, we actually have something that's wrapping it into a Tauri app. And then we can have an installed experience as well. And I made a template because that's kind of what I do most of the time. So this brings you like a lot of like sensible defaults if you want to package your app. Sorry, if you want to debug it, and it's open source, it's a little package you can do. Like, I suggest you're using dgit, but you can also hit the button on GitHub. And if you go through the whole like little system requirements, you have to do that for like mobile apps. I mean, Android and iOS. You can actually build the 2 apps at the same time and your web app and have everything running at the same time with hot module replacement. It's pretty cool. And my template's like opinionated. You have Solid, you have Tailwind, and it's already set up for you with some defaults for best security and performance. And that was kind of it. Thanks a lot. And you can find me on YouTube or X or anything else. Thanks.
Ramona, do you want to get set up?
Mm-hmm.
you should be able to apply them to other frameworks like React or Angular or whatever you are working with. So please don't be worried, but let's get right into it. Well, 45 view. If I think about fortresses, when it comes to, actually no matter if it's about web applications or in real life or in movies, media, books, I always think about fortresses to be there to protect something precious, right? May it be your peers, may it be a city with lots of people, or may it be your application with its features and its data, for example. And those fortresses, if we widen the scope a little bit, you can see them often in movies. And the first movie I think about when it comes to fortresses is Lord of the Rings. And I really loved it. I guess I read it at the age of 12, 13. I know I'm nerdy, I'm a book nerd, I'm sorry. I'm actually pretty sad I'm not in the other room when it comes to this library walls, unfortunately. But still, we have a movie theater right now and have a fortress in it, especially when it comes to Lord of the Rings. There are many fortresses, of course, but I think about one fortress a lot when it comes to protecting stuff. It's the one of Helm's Deep. It was meant as a refuge for the Rohan people, Rohirrim, and they should have been protected from the assault of the Saruman forces, right? And they said it was never conquered. Who else heard this statement? Like, oh, it was never conquered, it's safe, nothing can happen, nobody can break into our applications. Bold statement. And not only when it comes to other areas like testing, we are 100% secure, nothing will break. It can be the same with security as well. So it was with Helm's Deep, you can guess. Well, at least one of the parts of the fortress didn't hold. As you see, there's a little, how is it called, covered, which is the weak point of this fortress. And I guess it's a common weak point when it comes to all media. I say, hello, Death Star, you should be able to cover those little weak points, right? So the Uruk-hai, this Saruman force, blew it open. And in the book, they don't even need to blow it up as it was a gutter to it. And that leads to this fortress almost being overwhelmed. Why do I tell you that? No matter if you know Lord of the Rings or not. Your application's protection can be regarded as a fortress too. There are lots of precious data, lots of precious features. Maybe if you want to charge your customers or make money to have a little salary or something, you really need to protect the insides of your application against outside threats or outside people or just people who you don't want to access those parts of your application. And never ever say it's not able to being broken, because the world changes, more vulnerabilities will come up, and even no matter if it's a web application or a fortress in Lord of the Rings, as Thielin said, never feel too safe. So as developers, we need to take our part into building our applications responsibly and minding security and minding the trust the user will instill to us, right? Okay, so to think about how can we protect our applications against outside threats, we first need to find out what are the most dangerous risks when it comes to web development, right? And there's a community, a group, which helps us with that. Who of you guys heard of OWASP before? Wonderful, there are a couple of people and I love that. So this is actually a project which helps us when it comes to keeping our applications secure. OWASP is short for Open Worldwide Application Security Project, and their goal is to keep or to raise the security in web. And for this goal, they published a ranking. I guess the last one was in 2021, if I'm not mistaken. And in it, we will have the most important security risk ranked. And we will take a look at 2 of the 3 most important ones, and in one, we will dive a little deeper in specific, even though we just have a limited time frame, so I'm sorry I cannot do a deep dive, but at least I want to get you started on it. Okay, the top 10 look like this. We will have those 3 points. And the first I want to take a look at is the broken access control. And although it's dealing with security risk in authorization, I do think that authentication, so being sure that the user who wants to enter protected content or wants to access your application is the one you are thinking it is, it still belongs to this most important security risk, because authentication is the first step to authorization decision. So you need to know who your user is before you are able to determine what they are able to do or not. As we are having a talk targeted to front-end developers, it's not completely the focus of this talk, but I still want to give you some guidance. And the first easy improvement, if you think about a login form with username, password, or basically any kind of authentication, is the following one, and it's easy. Please mind your error messages. Think about, okay, I want a user to enter invalid credentials, and if you say like the password is wrong, a possible attacker might know that he needs to try out more passwords, right? So like try to find some generic error messages for authentication. Maybe wrong username or password, or wrong credentials. So the attacker cannot guess which one of the data is wrong. Another thing, especially considering DDoS attacks, so if people just try out some random password combinations, is having a rate limit. So you will block the authentication of your application as soon as there's a certain threshold reached. May it be like, let's say 10 login attempt inside of like 5 minutes or whatever fits your best. But try to limit it so the people cannot just try out millions of combinations, right? Of course, you can think about using third-party libraries like Auth02. So if you want to learn more about it, as said, I'm just 5 minutes away from here. But no worries, I will not cover it in depth right now because there are more interesting points we can take a look at as front-end developers than just all of the things of identity topics, right? Or if you want to build it yourself, which might be a little intimidating, but if you want to, consider other things like JWT tokens, a token-based authentication, or something like that. Okay, I said there's one other point in this top 10 ranking I want to talk about, and I want to focus a little bit more. It's maybe something you already stumbled upon because it's pretty common. I guess when it comes to CWEs, most of the risks in it are connected to the third rank in this ranking. It's on injection. So to sum it up real quick, an injection is an attack where an attacker supplies untrusted input to a program. And the input will be executed as if it was the program's code, which is really scary, especially as hackers might not be using kind things when it comes to their code, right? So in general, it means that the input gets processed by an interpreter as a part of a command and query, and this alters the execution of your program with the parts the attacker will inject to it. That's injection. And to be specific, this includes cross-site scripting too, or XSS. So might be this, or SQL injections if there are some backend engineers here. There are lots of angles you could use, like imagine some user supplies data. Prime example, an input field is not sanitized, filtered, or validated. So this typical, okay, I'll enter its script tag and it will be executed by the program. Maybe don't do this, please. Or having dynamic previews or non-parameterized calls without context-aware escaping, or even worse, using malicious or hostile user input directly or inside of your queries. Well, this sounds pretty bleak, right? But there are some ways on how to prevent it, especially in Vue. But as I said, I try to be agnostic too. So how to prevent it? And this is the most fundamental thing to take care of. Never, ever use non-trusted content as your component template. At least in Vue.js, I can imagine it's similar with other similar frameworks. Just don't do it. Because if you are doing some stuff like this, like here, a user-provided string, it's equivalent to allow arbitrary JavaScript execution inside of your application. And you will never want to do that. And even if it's just like not giving up the control of your code, this is like directly open up the doors for attackers. So just don't do that, just don't do it. In Vue, templates are compiled into JavaScript, and expressions inside templates will be executed as part of the rendering process. Thus, Don't keep your doors open, don't do this. And please don't expect Vue to shield you from those things completely, because it's impractical for a framework, not only because of performance issues. So please be mindful, please don't rely completely on the framework, even though they will help you. They cannot handle everything for you. So just don't do it. I cannot stress it enough, don't do it. But still, first line of defense is your framework, which means Vue can help you already a little bit. They don't leave you completely alone inside of the open, right? Let's take a look at that. So, as you might have guessed by me introducing what injection is, I already spoiled a little bit how to prevent it the easiest way. It's by using proper escaping of content. Maybe escaping strings, special characters, so script cannot be executed in any way if they are user provided, as you see here. So if you have a user provided string and you will enter such a script tag, maybe an input field or whatever, we will have a look at some other angles too. It will be escaped to, for example, this one. I guess, yeah, there we go. This one, which makes it impossible to be executed inside of Vue. And when it comes to Vue.js, this escaping is done by native browser APIs like text content. And this makes it pretty safe, as if this angle of escaping is broken, it's broken in all browsers, right? So I guess it's a wonderful way of at least supporting us when it comes to be protected and to escape content. And it's not only when it comes to HTML binding, it's also when it comes to attribute binding. So these are the 2 points where Vue will help you stay secure. But as said, Vue does a lot, but it cannot be the only thing you rely upon. We are still the most important line of defense. How we build our applications, how we deal with this responsibility is even better, because it's like the last line of defense and the most important one. Like in Helm's Deep, where this part of the fortress was not breached, right? So what can we do to stay secure? First, sometimes people forget about URL as an attack vector, but if you have user-provided URLs, they could contain wrong redirections or JavaScript embedded in it. So please mind escaping your URLs too. If I think about cases on how to attack in this angle here, like here, it might be like phishing by constructing and entering URL inside of the application, which will be embedded here, or even if reflected score strictly attack. The URL isn't being displayed in the web application, but still the attacker could add some JavaScript inside of this URL. There are some libraries you could use to keep them sanitized, like sanitize-URL to help, but still there are not that many possibilities inside of the front end. So please mind your backend on this regard. So either use libraries or try to have your backend to sanitize user-provided URL before even being saved to the database, right? And mind that URLs can always lead to unsafe destinations if they are not like hosted and controlled by your own. They could still be like hijacked at the like server provider's site or something like that. So please don't feel completely safe, even though you try to keep them safe. Another angle, which I, as a front-end developer, was a little surprised of, was styling. Sometimes you might have user-provided styles, as you see here, where user could still, like attacker could still provide CSS to click check. Think about a UI redress attack. So picture a little login form with a button to log in somewhere. The button is provided by you, but if you have user-provided style, the attacker could put a hidden UI and control, which is like in front of your own button, and leading to like a fake login page, right? So think about such UI redress attacks. You can prevent them by allowing user-provided style only for certain styles, which are considered safe. May it be a, there we go. a background which is not able to have a complete styling change, right? Or let's say a color of a font. So keep the possibilities for the user to alter your styles to safe destination, or even consider a complete sandbox iframe where they can't hire anyone. This point could be also interesting if you're using properties inside of your Vue.js components. So it might be an idea to have object syntax and only allowing users to provide values for specific properties where it's safe for them to control. So be really mindful where you allow users to style things, to provide things, to basically interact with your application on such a level. Yeah, like I do here. And last but not least, JavaScript injection, which is maybe one of the most obvious parts where we could interfere and have user-provided ones. And my answer is pretty easy. Don't use script elements in Vue. And even if it's just for avoiding templates and random functions with any side effects, right? So you don't want to mess up with your code when it comes to that. And do the same with events too. So if you have event attributes, please don't use any user-provided JavaScript here, like a click or hover or any other event. Okay, last but not least, but it's still one of the most important points, which is an easy point, which is coming up, but still I get, especially in side projects, that people don't always mind it as they should do. If your product looks like this, please be careful. Please don't do it, because you should need to keep your NPM packages, Vue.js itself, and all dependencies updated. And there are a couple of ways which are not that difficult to use, like the Dependabot if you're using GitHub, or like npm audit as a command to always keep your dependencies up to date. Another link, which I'm not sure if you can see it through the banner, but it might be worthy to take a look at CWE databases too, because there are all updates when it comes to new vulnerabilities, and if you really need to update or if you got some days time, right? For example, I guess I opened up a QR code for the Vue.js ones. These are the publicly disclosed vulnerabilities you might need to take into account. Okay, so these were my first best practices to take a look at. I would love to talk with you about more best practices or go more into depth, but I want to be mindful of your time. So let's quickly sum up what I want you to remember from this talk. It's those. Vue.js is the first line of defense. It will help you when it comes to building secure applications, but it's not the only one. So the first thing which you always need to take care of is not using any non-trusted template or templates you don't have inside of your own control, because you will keep your doors open if you do. Then you can apply lots of small best practices, which I already showed. I will share the slides later in Twitter too, so you can have a look at them later too. But they are like small, low-hanging fruits to utilize, and they will not eat up that much of your time. So why not using? And last but not least, might be annoying, but mind your dependencies. Yep. One point, if you notice some vulnerabilities or some security issues in Vue.js themselves, please contact them. As far as I know, they will be immediately becoming top concern, and I guess there's even a full-time contributor which will directly work on it. So if you experience or see any issues, please contact them at this email address, so we can help keeping Vue.js secure, like in the future too. I gathered some resources or more best practices you might want to take a look at, and the Vue.js SDK of Auth0 if you want to have some library for broken access control for the first rank in the security ranking of OWASP 2. But you can find me at our booth too if you want to learn more about that. And well, what's left to say then? Thank you so much for listening to me. I'm happy to meet you later on. I'll be mingling around, or I'm at the booth, and I would love to talk with you. So thank you so much.
she said, like if you want to have a chat with her, try and find her at the booth in front. Talk. We're going to hear an interesting discussion about Airbnb's decision to get React Native. Please give a round of applause.
Good morning, everyone. Thank you for coming out to this session. Big thank you to Eris and Milos and the rest of the organizers for CityJS for doing this conference. It's my first time here in the London one, and super excited to be with you all. So this talk is called Sunrising React Native, Why Airbnb Was Wrong to Ditch React Native in 2018, which is a not so subtle dig at the article that Airbnb wrote called Sunsetting React Native. So we're going to jump into it, and basically this is an intro to React Native, a very quick refresher, what's been happening in the ecosystem as of late, so going into 2024 now, and then deconstructing some of the talking points in the article and talking about why they're no longer relevant. So as Milo said, my name is Mo. I am the head of mobile at a company called Theodo, based out of the UK. So Theodo is actually a global consultancy. with around 700 people between the UK, France, and the US. If you're in the React Native ecosystem, you may know the name BAM. That's one of our sister companies. And we've been doing open source in the React Native and mobile ecosystem for quite a while. So we built libraries like the React Native image resizer. And more recently, we built Flashlight, which is Lighthouse for mobile apps. So you basically drop in an APK, and you'll get performance tests on how quickly your app is running in terms of the FPS, CPU, so on and so forth. So give it a try. So I was actually on vacation last week and this week, and I came back to the UK last night, and I had an interesting thing happen to me. So as I was coming into the country, you get stopped at the border, and I'm sure you've all been asked questions before, like, what do you do? What's your job? Why are you here? So on and so forth. So I got asked, what do you do? And I said, mobile development, to which surprisingly, the border officer said, do you specialize in Swift or Kotlin? Now, at this point, I'm a bit taken aback. And I say, I mainly focus in React Native. And I said this almost shaking, because I thought he was going to deport me for saying that. And then he asked me this, which was, what's the point of using React Native when you can use Swift UI or Jetpack Compose? Which, at this point, I was just like, who are you, and why are you taking my details? So this was not the conversation that I was expecting to have at the border. But it's a conversation that I'm all too familiar with working at a consultancy. So when you work at a consultancy, you're regularly asked questions like, should we really use React Native for our next mobile application? Is React Native actually stable as a technology? And then, you talk through these points and you tell them, no, it is actually stable. It's a good technology. Then they'll ask, well, are there actually any serious apps built with React Native? Like, is it just hobbies and side projects? And after you go through the rounds and you answer all these questions that you've done 100 times, isn't native better anyway, right? And so there's almost always a cloud of judgment around React Native. And there's a cloud of fear, and people are not sure if they should really trust React Native. Can you put the success of your company at stake because of using React Native? And if you dig a little bit further, it usually comes from this lovely article called Sunsetting React Native. So this was written in 2018 by the Airbnb engineering team, wherein they say, due to a variety of reasons, technical and organizational, we're going to be retiring React Native and focus solely on native instead. So this was a big deal for the ecosystem back in 2018. How many of you have been doing React Native? Show of hands. OK, so half of the room. How many were doing React Native in 2018? OK, one person. So maybe two. So if you were around during this phase, it was a big deal because everyone was thinking, React Native is going to die now, because Airbnb was a big player in the ecosystem. They had a lot of open source libraries out there. They did a lot of thought leadership in this space. And suddenly out of nowhere, this came out and everyone was like, oh, wow, maybe this tech isn't that good. And at this point, everybody thought React Native was dead. So today, we are going to dispel of this notion. Firstly, we're going to look at what is React Native. Thankfully, a lot of you haven't done React Native, which makes the next few slides not redundant. Otherwise, we'd all be bored. So we're going to talk about what is React Native from 3 angles. Firstly, how does it work? Secondly, who uses React Native out in the wild? And thirdly, what is the future of React Native? So how does it work? Show of hands, how many people use React at least? Great. All right. So if you use React on the web, typically what we refer to as React on the web is actually 2 components. One is React, which is the UI library, and then there's React DOM, which takes whatever your UI is and translates it to DOM-compatible code. So React is actually just an agnostic UI library. It doesn't care if you're working in the browser or if you're working on a mobile app or on a TV or even a CLI. I know people who have written CLIs in React. I'm not saying you should do it, but I know people have done it. So what React Native does was, let's go back for a second. If you have the React DOM, it basically gets rid of just the React DOM layer and replaces it with an app registry. And this is a React Native specific thing that basically talks to the native layer and does what React DOM does, effectively the rendering layer, but on mobile and native devices. Now, this is a gross oversimplification. If you want to actually look at the architecture, it looks a little bit more like this. And even this is a gross oversimplification. But really, what this is trying to get across is that there's sort of 3 layers. There's the JavaScript layer, there's the C++ layer, and then there's the actual platform that your code is running on. And so you've got React code in your JavaScript layer. There's things called Fabric and Turbo modules, which handle the communication with the native layer. I won't get into too much detail there. And then in each native platform that you want to run your application in, there is a JavaScript engine. This can be JSC, but it can also be Hermes, which is a Meta-created JavaScript engine specifically for React Native. And let's see how it works. So basically, we have a bunch of primitives in React Native. Let's use the view, for example. The view is the equivalent of a div in React. So it's just a section of the page or the screen. So what happens when you have a view in React Native is it kind of goes through this middle layer and some magic happens. And it basically spits out an Android view and a UI view. So the Android view is the native layer Android view that you get when you create a native app in Kotlin. The UI view is the Swift equivalent on iOS. And so basically it just feeds those there and renders them on the native layer. And all of this is to say React Native is native. Most people, when you speak to them for the first time, they think React Native is something like Ionic. It's a web view or something like Towery we saw a bit earlier, where the UI is being done on the web, but maybe some of the underlying logic is being done at the native layer. React Native is actually quite different to that. React Native is actually rendering views and elements directly on the native layer. So you are getting fully native components in your application. Another way to think about it is, in a React Native app, you've got two layers. You've got a JavaScript layer and a native layer. The JavaScript layer is in charge of coordinating and basically layouting and rendering and orchestrating what the native layer comes up with. So that's just a brief explanation of how React Native works. Now, who uses React Native out in the wild? So React Native is a massive open source project. The actual repo itself has got over 100,000 stars. And it's obviously maintained by Meta, among others. So naturally, you'll have Meta using it themselves. So Meta will use it in the Facebook app, in things like Ads Manager, in Oculus. Recently, Amazon actually came out and said, we've been using React Native for years, and none of you found out, haha. And they use it in Amazon Photos, in the shopping app, and in Alexa. Microsoft uses it for most of the serious mobile apps that they have. So Office, Outlook, Xbox Game Pass, which is definitely a serious mobile app, but you know. But they use it for all of these, despite them having .NET MAUI, previously Xamarin as well. They have those UI libraries that they've built internally, but React Native is still the mobile app development framework of choice for them. And of course, there's Shopify. So Shopify uses React Native for most of their apps as well. And now, why this is important is not just to say big tech is using it, but it means because big tech is backing this, and it's not just Meta that's backing React Native, a lot of great open source is then fed down to the community. So obviously React Native is open sourced. Meta also open sources Hermes, which is a really hyper-optimized engine to run React Native code on a device. They open source Metro. Metro is a bundler that's, again, hyper-optimized for React Native. Windows, Microsoft is actually maintaining the forks of React Native for Windows, for Mac OS, and they also release a bunch of tooling out there. And so does Shopify. They have Flash List, which is a hyper-optimized list that's virtualized and so on and so forth, along with Skia and Restyle. So those are for canvas and styling functionality. So this is big tech, but obviously, when you look at the App Store, a lot of applications are actually built in React Native. So these are some of the top chart applications. Somebody in the community called Evan Bacon actually takes these screenshots and highlights which ones are React Native. But you can see a lot of apps are actually built in React Native out in the wild. Apps that you might have used. This is from the US App Store, but it's very much the same. And you'll see React Native is the most dominant cross-platform framework out there in the app stores. So those are just some of the users of React Native. And now let's talk about the future. So there's a conference in Poland called App.js, and this happened in 2023. One of the speakers, Fernando Rojo, did a talk called React Native 2030. If you're interested, I would highly recommend you watch it. But I've basically referenced him because I've ripped off this slide from his talk. So this is a slide talking about the problems that we face as a community. These are the challenges that people have typically had with the React Native application. And slowly but surely over the years, there's been answers to each of them. We've had slow lists. We've started to see the use of Flash List, a library that will make it significantly quicker. We've had toast solved by a library called Burnt. Modern CSS is starting to come into React Native. Images are getting better, so on and so forth. So there's a lot to be excited about. And I kind of want to go through a few of the things that I'm very excited about, what I think are the next big things. And this is, again, subjective, but bear with me. I think these are some cool things that are happening in the ecosystem. Firstly, it's getting significantly simpler to integrate with native layer functionalities. And so if you have a bare React Native application, you can use turbo modules, and there's some better renderer interoperability. If you use Expo, how many of you have heard of Expo? Great, okay, cool. So if you use Expo, you can use config plugins to actually go in and modify the underlying native configuration of your app. You can also use the Expo Modules API, which I think is really cool, and I'm going to show you how this works, because basically with the Expo Modules API, writing native layer code is so simple, and you can just reference it within your JavaScript code as if nothing has happened. It's actually a really cool API, and there's a lesson to be learned about good API design here when you're doing multiple languages. So let's say you want to write a native module, you want to access some native layer code in Android and iOS. So they've defined this API where you basically define a module, and it looks very similar despite the languages being different. And it says, I want to define a module called Expo Settings, and basically what I want this to do is to get the theme. So this is just a simple function, but you can obviously put any native code you want here that's running on iOS and on Android. And the actual syntax is very similar. So what is this? Maybe 10 lines of code. Then on the TypeScript side, you do a module definition. So you say, I have this new module that I've defined that has native layer functionality. And there's a function there called getTheme that returns a string. And it basically just calls that native layer functionality. So that's on the TypeScript side. And that's it. You can basically start using that inside of your React Native application. And it's less than 20 lines to be able to basically write native layer code as if nothing. So that's really quite cool. And something that would significantly take a lot of time previously has now been reduced to something like 20 lines of code. And what this basically means is that you're bridging the gap between native and JavaScript. And all of these are coming closer and closer together. And we're all celebrating and having happy days. So yeah. Now, as we go into bridging JavaScript and native more and more together, we reach this concept of universal apps. Universal apps is actually quite a cool idea. It came and kind of prospered from the community quite soon after React Native itself was created. So if you go onto the React Native website, it on the subheading basically says, learn once, write anywhere. So it doesn't imply that you can basically write one code base and just run it on any platform. But the idea is it's just one language and one framework for you to learn. The idea with universal apps is that people thought, well, I don't want to actually do that. I want to take it a step further, and I want to actually write once and be able to run this anywhere. And so you can have a single code base that runs on iOS, Android, web. Maybe you can make a web extension, TV apps, so on and so forth, desktop. So obviously, this is quite different to Meta's philosophy around how they want you to use React Native or how they use React Native specifically. But this has changed in the last few months. So traditional React Native code looks something like this. You can use something like style sheets. This is just using the bare primitives from it. Obviously, there's abstractions on top of this. But you can use the style sheets to create your styling. And then you have views and text, which are those generic primitives that you're using. A little bit different to React, right? So if you're a React developer coming from the web, this might be a little jarring because you're used to using DOM elements. And so this is a little bit difficult to ingest. At the same time, people want to use React Native for web, right? What does a text equal in the web, right? It's not necessarily clear. What does a view equal on the web? It's not necessarily clear. So Meta has been secretly, to some degree, working on React Strict DOM. Have any of you heard about this effort? Amazing. Cool. So React Strict DOM was basically this effort to say we need to bring the web and the native layers closer together in terms of the APIs of React. And the way that we're going to do that is we're going to define a subset of the DOM that we can comfortably support on both web and mobile. And we're going to make it more and more similar to how you would basically create a web React application. So you can see it starts to look a bit more familiar. You import HTML and CSS from React Strict DOM. The CSS is basically using StyleX, which is Meta's styling framework. And then you just use divs, H1s, P elements, and it all behaves and actually functions as if you're writing a React web application. I'm sure somebody will write a Babel plugin where you don't even need to write the HTML dot. So this is the step that Meta's taking it, and they're actually using this within their production Facebook app now. So this is a big deal. It's actually being used out. They're dog fooding it. which means that I think there's going to be a lot of effort going into this. And soon using React Native will mean that you can target everything. You can build a web app and a mobile app in a single go, which is really quite cool. So before this React Strict DOM stuff came out, we were actually doing some stuff like this as well. So we've had a few projects where we've been doing universal apps. And it's quite cool because we've basically taken teams that were traditionally separated by web, iOS, Android, or web and native, and we've basically split them off into almost product streams. So there's a team that handles, let's say this is a streaming platform, there's a team that handles the listen functionality, so it's podcasts, audio. Then there's a team who handles the watch functionality for the streaming, so on and so forth. And each of these has really just stuff related to that section of the product. It's the business logic, any components that are custom to that specific feature, and then if there's any iOS, Android, you can use Expo modules, and so on and so forth. So what that means is the teams are now like kind of transposed to a certain degree. Instead of separating your teams out by the tech, you've separated them out by the product and the feature, and they significantly understand the domain that they're working on better. And so if you might have heard of this before because this isn't a novel idea, but the next natural step with this would be micro-frontends for mobile. I'm disappointed Luca Mezzalera is not in this room. Yeah. So micro-frontends has been around for a long time. Webpack has module federation. And so there's already been an effort to basically take module federation and bring it over to React Native. So some people have made Repack, and Repack is basically a replacement of the bundler. So you use Webpack that's compatible with React Native, and you can basically have micro-frontends in a mobile app today. The challenge with this is you are basically getting rid of a lot of functionality that comes default to React Native because you're replacing the main bundler, Metro. And so Metro specifically does not support module federation. And a lot of the ecosystem is actually moving away from Webpack for web to Metro when it comes to the React Native web community. So Expo, by default, would have Webpack installed when you would want to target a web application using Expo. They've now made Metro the default. So we've almost got this divergence within the community, and people want to tackle the web side of things in a different way. And I'm quite excited for Metro to eventually have module federation because I think that consolidates these efforts and brings native micro-frontends into large-scale applications, and I think that's quite cool. So we've talked about React Native, how it works, usages, the future. Now let's talk about the spicy stuff. Let's go into that article. So if you actually open up the article, it's about like a 3 or 4, 5-part series article, and it's not all doom and gloom. It's not all bashing React Native. There's actually a lot of positives in that article. You know, back in the day, they were getting cross-platform at a speed that they had never seen before in their teams. They liked having React and the paradigm of React because back then, you know, declarative UIs were not as straightforward or almost non-existent with Swift UI and Compose at that point. And so what went wrong here? There's a few things that they mention, and we want to kind of go through them one by one. So firstly, one of the major things that went wrong was that there wasn't a good way to link into the native ecosystem. These days, you can use Expo's SDK. We saw the Expo modules API where it makes it so easy to integrate with the native layer, right? So a lot of these things have changed. Type safety was a big issue for the Airbnb team. They had a lot of bugs, and it was because, well, there was no sort of de facto way to handle type safety in the JavaScript ecosystem at that point. TypeScript 1, great, that's the default in React Native now. So if you start a React Native project, it comes with TypeScript as the default. You have to opt out of it. One of the other things was performance. So different JavaScript engines on iOS and Android had different performance. So on iOS, this was fine, but on Android side, the startup of an app actually increased quite significantly because JSC on Android was significantly slower. So this is a little demo here. On the left-hand side, this is an app running on Android without Hermes, and on the right-hand side, this is an app running with Hermes. And so Hermes was then built by Meta to basically tackle this specific problem, which made the startup times on Android significantly quicker. And so that sort of issue with the performance was significantly improved on. They mentioned lists, oddly enough. Flash list, we talked about it, but if you see the left-hand side is a regular list in React Native, the right-hand side is flash list. The left-hand side stops when the JavaScript thread gets blocked and it's loading new content for the list. The right-hand side is a list that's just virtualized and keeps going. The screen recording is not very good, but yeah. And lastly, one of the other things they mentioned was upgrading React Native versions was a pain. Now, if anyone's done upgrading React Native versions, they can attest to this. It is actually quite painful. But more recently, there's been the upgrade helper that the community's come up with, which makes this significantly easier. It gives you diffs from every version to other version of React Native. It also, if you use Expo, you get Expo upgrades, which is just such a pleasant experience, and it's basically a CLI command with some minor modifications to upgrade your app. And Microsoft, more recently, has actually created some tools to actually bootstrap and upgrade, make that process of upgrading significantly more automatic on a bare React Native application. So there's a lot that's happened here. Now, this article came out. What's happened since in this space? Well, firstly, Shopify, 2 years later, decided we're going to write a very public article and say we're going full in on React Native and we're basically investing in this heavily. And that's still been the course till today. The CEO of Shopify, ironically, has been just throwing digs at the Airbnb mobile team, saying, haha, you missed out on the treasure that is React Native. So he's having a fun time, I guess. And then last year, and this was a very exciting announcement, Amazon actually publicly announced that they've been using React Native for a really long time. So that was great news because another big tech backer came in and endorsed React Native and actually showed that it's being used out in the public. So all of this is to say, there's a lot of exciting stuff happening in the React Native ecosystem, in the community. There's people that are far smarter than I am working on some really cool stuff. And I hope you have become as excited as I am for what's in store in the coming years, because I do believe that there is an incredibly bright future for React Native. Thank you all very much for listening. Thank you.
big round of applause for Manfred Steyer talking about change rules, architectures with lightweight stories.
Thank you. Thank you. So what I have here is the best image you want to see before lunch. Namely, this is what we call in Austria a Krapfen. Some people call it a Berliner or something else. There are different terms in Germany. And Krapfen are mainly used during Carnival, not only, but mainly. And you can imagine them as a donut without a hole in the middle. We don't have a hole because normally we fill them with jam, and a hole would be quite counterproductive there. And as those guys are used mainly during Carnival, some people always try to be funny and don't fill them with jam, but with mustard. Yeah, that's really mean. They pick out one of them and exchange the jam by mustard and put it back. And then it's kind of a lottery for you if you choose the one with the jam or with the mustard. And if you choose the wrong one, you have a bad experience. As you can tell, Krapfen and mustard don't go together that nicely. So this is really mean, but quite a habit there. And I think it shows that even a small change can have a huge impact. And perhaps this is also the case for exchanging Redux by something else. I think all of us know Redux. For some time, it was the go-to solution for state management, but nowadays it's challenged. We have a lot of alternatives there, a lot of lightweight stores, and perhaps we have such a situation when we exchange a Redux-based store for a more lightweight one. And this is what I want to investigate here in this session. I want to tell you what will change when you go with a lightweight store in terms of your architecture. If you're wondering what I'm referring to when using the term lightweight store, well, it's basically some kind of store that provides just methods. I can call those methods. They will trigger some action. It can be an synchronous or an asynchronous action, and this action will lead to new state. New state that is propagated down using, observables or signals or something else. And out there is really a huge range of such stores. Here you find some of them, but there are even more. Perhaps you have looked into SolidJS. Who is using SolidJS? Okay, almost no one. But also SolidJS comes with such a lightweight store out of the box. It's baked in. So what's the agenda of all of this? Well, I want to start with a baseline architecture. A first architecture we will use for discussing how such a lightweight store can change our architectures. Then I want to answer several questions like how large should it be, where to put it, and also what to do with global and or local state. Another question is about preventing cycles, redundancies, and inconsistencies, something Redux is really great at, isn't it? For some reason, I hear myself here. Let me just check this out. Okay, great. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm doing a lot of trainings and consulting. And besides this, I'm also quite connected to the Angular community. I live in Austria. This is where we have Krapfen, as you know, meanwhile. But I also do a lot of stuff in Germany and all over the globe. I'm always happy to work together with people around the globe, remotely or on site. Okay, cool. Let's get started with my baseline architecture. And as I'm an Angular guy, I will use an Angular-based stack, but no worries. If you don't use Angular, everything I'm saying here will also apply to your stack, because all of this is more on a conceptual level, on an architectural level. But here I'm going with Angular and the so-called NShareX signal store, which is quite a new store and a quite nice example for a modern lightweight store. So what does my architecture look like? Well, the thing is, we are working together with a lot of huge enterprises. And so what we always try is to decouple or to subdivide our applications into something we call business domains. Business domains are areas from the real world we try to mirror in our application. And perhaps if you write an application for airlines, you might have a booking domain and a boarding domain, and you might have some shared stuff in there, stuff that is used in all the domains. And then we start to fill those domains that can be parts of our mono repository, just folders or libraries. We fill them with so-called modules. And also those modules can be just folders or packages, libraries, as you wish. We have categorized those modules. For instance, we have feature modules with smart components. We have UI modules with dump components. They are more reusable. That's why we put them into separate modules. We have data modules for data access and data structures, and we have utility modules for general purpose utility functions like authentication or calculating dates, stuff like this. And having an architecture like this matrix, has several advantages. First of all, it brings a lot of order into play. There is less discussion about where to put something and where to find something. Discussion about this is nothing you need when you have a large team or several teams working on this. Then it should be clear where to find something and where to put something. This is one advantage. Another advantage is you can now introduce simple but very effective rules, like you can only navigate top-down here, which means that feature can access everything below it, which would be UI, data, utility. And also data can only access everything below it, which is just utility. This prevents 4 cycles, and this makes sure that not everything is intermingled with each other. Talking about preventing that everything is intermingled with each other, perhaps this here is the more important rule, where we say that code from one domain is only allowed to talk to other code from its own domain and with shared code. So in this case, booking is allowed to talk with booking stuff and with shared stuff. Boarding is allowed to talk with boarding stuff and with shared stuff. Booking and boarding are not allowed to talk to each other. This also prevents that everything is intermingled, that you change something here and break something over there, which is quite an awful situation. The thing is, somehow we need to enforce those rules. And for this, we could go with Sheriff, which is a nice open source project a colleague of mine wrote. And it allows you to define that this folder is only allowed to access stuff in that folder, to import stuff from that folder in terms of ECMAScript modules, but not from these folders over there. And now let's have a look into a first demonstration about all of this. So for some reason, I still hear myself here. Why is that? Okay, good. So let's have a look into an example. Perhaps it's this guy here. I'm not sure. But what we have here is a very simple example. And this simple example is for searching for flights. You can click here and then you can book your honeymoon. London, Paris is a typical honeymoon, someone told me. And yeah, then we find some flights. So it's really as easy as possible, but as complex as needed to show all those concepts. If we look into this application, we see here our flights application, and it has a domain folder. And if we drill in, we see all our domains, all those areas from the real world we want to mirror in our application, and we want to decouple. Perhaps different teams work on them, so we really want to decouple them. We have here check-in, luggage, the shared stuff, and ticketing. And in here, we have 3 libraries in 2 layers. We have 2 libraries from the feature layer, and we have 1 library associated with the data layer. And if we drill in here, feature booking, then we see here a component flight search. And you see a lot of ECMAScript imports. However, this one is not allowed, because here I'm in the ticketing area, in the ticketing domain. I'm not allowed to grab over to a foreign domain that might be supported by a different team and import something from there. It's like going into a different building and taking something out of the fridge. It's not considered that polite in most countries I'm aware of. So if we really try to import stuff here, Sheriff, which is basically a linting rule, tells us, hey, Manfred, what you are doing here is not allowed. You don't have a clearance for grabbing over to there. And this is great, because this allows us to enforce our architecture, and this makes sure we don't have any broken windows anymore. You can also use this like a unit test when someone wants to land their pull request. If they violate this rule, then they are not able to land their pull request. Besides this is a simple component. It is using a simple store. It is delegating to the store in terms of getting some data from the store. In this case, it's signal-based data, so it's reactive. From will tell us when it has a new value, and to will tell us when there is a new value. And in terms of methods, we are just also delegating to those methods. So we are sending a method up and some data comes down, really a simple, lightweight solution. Okay, so this was our baseline architecture. And now the big question is, how does this all affect the way we are working? And the first question that might come up there is, how large should it be? How large should such a store be? And this is quite an interesting question, because if we talk about Redux, it's glass clear. Then the Redux store contains everything. Then we have one big store, one single source of truth. When it comes to lightweight stores, we very likely have several of them, because a store is something like a file or a class, something that provides methods and data structures. And so we are here on a feature level. That means we need several lightweight stores, one per feature, or if this feature grows too huge, we need one per sub-feature. We break it down into parts of our features. And this might be necessary because everything that belongs to a lightweight store is usually put into one file. This is also a big difference to Redux, where we have several files that describe the whole store structure, the reducers in there, the actions, and so on. So we are here on a feature level or a sub-feature level. The next question is where to put the store. And this question should be seen in the light of this architectural matrix. Also here, funnily, if we talk about Redux, the answer is quite clear. Because Redux has a notion of a feature slice. And so it's somehow clear that the feature slice is associated with the feature level. And sometimes people put it to the data level because they say, well, perhaps we have several features that need the same state. Perhaps we have several features in booking that need your tickets. Then we just pull it down. So in the case of Redux, it's glass clear one more time. In the case of lightweight stores, this leads to an interesting discussion. When we have a lightweight store, for instance, the store can live on a component level. Some people want to offload their state management from their components to make them simpler, and so they might just create one store per component. This is very local state for very component local state. It's an option. Some people might tinker a store for a feature, as mentioned before. Everything that is needed by this feature, by all the, let's say, 5 components of the feature goes in there. Some people might say, well, we have several features that need the same state. And so they might put it to the data level so that several features of the same domain, perhaps of the booking domain, can access it. You might even have state on the utility level. Not always, but it's possible. Not all utilities are stateful, but if we think about something like authentication, we for sure have a state there, the authenticated user and so on. So somehow we need to manage it, and we could do this by means of a store. And the last one is really funny, because it turns out that a lightweight store can also live in a dump component. And this sounds like a no-go at first glance when we come from a Redux perspective. Because in Redux, it's really a no-go that a dump component can access the store. But this is mainly because in Redux, we have global state in the store, application-wide state. And this is not the business of the dump component. However, a dump component can have some state of its own. Think about a scheduler component. It can be quite complex. It consists of a lot of subcomponents. And so it has a lot of states to manage, all the dates and the different options of dates and all the flags for the dates. And so we could really decide to have a little own store to manage this complexity for our scheduler component. However, the big difference here is this is an implementation detail of the dump component. So the dump component is not exposing this store. It's really an implementation detail, and it's none of our business if we are on the feature level. That means, and this is somehow funny, if you come from a Redux perspective, a lightweight store can literally live everywhere. We can define it for a component or for a whole module. And if we define it for a whole module, we can decide to expose it for other modules, or perhaps it's an implementation detail of the module. The next big question is what to do with global state and how to distinguish global state from local state. Well, here we are lucky, because we can really have stores on all the different levels, on the feature level, but also on more global levels. However, in this case, we might have the challenge that a feature needs states from different levels. Perhaps we need some state from the utility store that is managing my user data, and some state from my own feature store. And in this case, we can introduce a service or just a function that is orchestrating all those stores. Let me show you a simple example for this. So what I have here is your next flights. And obviously, to show you your next flights, I need to know who you are. That means I need your user ID from the utility store that is about authentication, and I need to know your flights, which are managed in the feature store of this very feature. So how can we accomplish that? Well, basically, we just need a function or a class or a service, it does not matter, that is orchestrating all those stores. Here I'm grabbing my out store, here I'm grabbing my ticket store. When I want to load something, I'm delegating to my ticket store. And here you see I'm calling load by passenger, and I pass in the current user ID from the out store. And as I have signals, I can also use those signals to compute new signals. It does not even matter where those signals come from. They can come from different stores. I can just compute the results of those signals together. For instance, here, I'm projecting the tickets of the current user to the flights that are associated with the tickets. So I think the key takeaway here is, if you go with lightweight stores, you might have a situation where you need to orchestrate several stores. The last question I want to answer is how to deal with cycles, redundancies, and inconsistencies. Well, and the answer is layering. These rules we have that one layer is only allowed to access layers below really helps to prevent cycles. And we can even introduce another rule that one store is not allowed to access further stores. In this case, we also prevent a situation where we need something from each other in a cyclic way. And of course, we need some dev tools, like the Redux dev tools that show us where we have which data. And so we can find out about redundancies and inconsistencies. But also this last point is not that different from the Redux world, because in the Redux world, when you subdivide everything into feature slices, you also could get redundancies, especially if another team is responsible for the same or for another feature slice. So also in this case, you need a way to observe the state in your system, and for this, the Redux dev tools are really great. And saying this, most lightweight stores also have support for the well-known Redux dev tools. So if you like those ideas I had there, you find even more in this free ebook. Feel free to download it. And now let's come to the conclusion. We have seen that a lightweight store has the size of a feature or a sub-feature. We have seen that it can live literally everywhere. We have seen that we can orchestrate several stores, and sometimes we have to orchestrate them with I call it feature service. In your case, it's perhaps just a file with functions, if you go with a more functional approach. And we have seen that layering prevents cycles. Also, we should use the dev tools. And there is a last thing I really want you to remember. Please, please always remember this very last thing, namely, Krapfen and mustard don't go together. Please prevent this joke. So thanks for having me. Here you have my contact data. Feel free to follow me on X, and I've already uploaded my slides and examples to my blog. Thank you.
The food is already being served in the main area, so feel free to slowly head out and grab some. Thank you.
I don't get the presentation. No, I don't get the buttons. That's weird. Showing my motion. Yeah. Yeah, it's working for me. Yeah, I think so.
Yeah, but that's the thing, okay, so this one is AI, then you have the same time, then AI for so they do the same thing, so I'm not sure.
we must have a global vision and not be stuck in our code. Code finally is a tool. So let's take a quick journey to the evolution of programming tools. Believe it or not, it begins by carving stones, because humans, as the first thing they found to store data was to writing on stones. And then paper was invented, and calculation machines, and pinch card. And finally, we arrive at our modern code editors and modern language. This is a difference between carving stones and real. It's huge than going to AI. And now we're stepping into the era of AI. Each step has brought changes and empowered us to be more creative by handling tedious tasks. The huge difference between these steps and the AI step is the pace. AI is going very, very fast. So we must adapt quickly. So this is a representation of Ada Lovelace, the first programmer. We did it, this is my boyfriend, we did it with German, he's really good at that. And so imagine Ada Lovelace with us today. Would she lost her job because of AI? I think quite the contrary. Think of what a brain like that could create with the tools we have now. Our everyday life would have seemed magical to her. You see her with a laptop now. Looks natural, no? And she was writing algorithm by hand that now we can implement in a few keystrokes. Our modern tools would amplify our genius, just like AI can amplify ours. Ada wouldn't be out of job. She would be leading the charge, innovating, and pushing boundaries just like she did at her time. Now this is Ada at the AI age. So consider Ada as a symbol of what we can achieve with AI in our toolkit. She harnessed the power of the analytic engine, and now we have AI, which is our modern day equivalent. So her legacy isn't just in her historical contribution, but in the mindset she represents, one of curiosity, innovation, and pursuit of knowledge. So with AI, we can ask ourselves, what would have Ada built today? The possibilities are limitless. AI empowers us to take on more ambitious projects, streamlines our workflow, and innovate at a pace that Ada would have dreamed of. So it's not that just AI makes us code faster, but this time we can put it to build other things, to augment us. So as Ada transcended the limitation of her time, let's use AI to transcend ours, to build things that we've never imagined possible. So now let's address the common misconceptions. AI can code, so we are not useful anymore. Okay, AI is powerful, but it's not infallible. And when it comes to advanced coding, a deep understanding of code is crucial. You have heard about the Debian assistant. Who are code about it? Okay, not so much people. So they announced this Debian thing that is the first AI software engineer. But guess what? The company behind Debian, which is named Cognitive, is hiring human software engineers. So think about it. Generate code, but it's our expertise that refines it, give it context, and evaluate its effectiveness. So this is a cyclical process of iteration, much like a dialogue with the AI to reach the best solution. So think about AI like of natural language as a new programming language. So to leverage AI effectively, you need to understand programming principles. So imagine you use AI to draft a basic legal contract. Okay, you can do it. But would you trust AI to more advanced legal matters? I don't understand anything about legal things, so I will never do that. I will ask to a lawyer. That certainly, or perhaps will use AI too, and then refine it. So I think this principle is true not only for us developers, but for every profession. So we're moving into an era where we will be working alongside with AI. We must evolve our skills. We must stay ahead of emerging technologies and methodologies in programming. So now let's dive into the practical application in AI development. So first, of course, AI allows us to code faster with Copilot, or there is other tools like I have tried, for example, Cursor. This is a code editor, exactly like VS Code, but it has AI integrated. I have tried pieces.app, which is open source, and you can have your snippets into it, and you can also keep memory of your chats. Source graph that I have not really tried with. There is many tools. So of course you can quickly create a component, for example, a form or whatever. You know how to do it, but why spend 10 minutes when you can do it in a few seconds and then refine it? But it can also fix your bugs, but not only fix them, but explain you what is wrong. So at the same time, you are learning, and sometimes it's wrong, so you are chatting with it. And one big advantage, and I think the ones that are really using it feel that it keeps you in the flow, because you are not stuck anymore. You don't need to go to Google to Stack Overflow and take the risk of being distracted by another website or whatever. You just stay in your editor and you chat with your assistant. And strangely, I feel also less alone when it's more fun when I code with Copilot, and sometimes it's wrong, but it works for me. So then you can learn with AI. You have a lot of GPTs for learning to code, so you can ask it questions and it will build a program for you with an exercise, etc. So that's another thing. You can also navigate documentation. For example, you need to do something with a new tool and you have all this documentation and you just pass it to ChatGPT or another model and ask it, okay, I need to do that. Can you explain me how to do that? Or if you don't understand something, say, okay, explain me that like I'm 5 years old and in French, please. And it does it. So. But AI is not just a coding or learning assistant. You can use AI to build apps that anticipate user needs, personalize experience, or automate complex tasks. So if you dream of launching your own SaaS, this is the perfect way, and there is a lot of opportunities now. And also, if you consider a career shift, the demand for AI engineers is going to be huge. And as JavaScript developers, believe it or not, your skills are a strong foundation to build on. So what is the learning path to become an AI engineer? So I feel that many of you are like that. Who is like that, thinking to become an AI engineer, they need to learn mathematics, data science, machine learning, deep learning, Python, etc. Who thinks that? And so they don't have time. Okay, almost everybody, most of people. Good. So I have good news for you. So this is AI, but you know, in this AI, we have all these subsets: machine learning, neural networks, deep learning, generative AI, and we are here in the large language model. And this is where we are going to interact. So this is a screenshot from Latent Space from Swix, and I really recommend to read this article. And it says that we are observing a once-in-a-generation shift, right. So we see we are here, full stack engineer, AI engineer, APIs. A shift, right of applied AI, fueled by the emergent capabilities and open source API availabilities of foundation models. A wide range of AI tasks that used to take 5 years, and the research team. So research team, you know, there is machine learning researcher, etc. To accomplish in 2013, now just require API docs and a spare afternoon in 2023. So this means that we are now not building models from scratch, but what you need is to know how to interact with them, mostly through APIs. It means that if you can make a web request, you are already in a good way. So I think everybody's in a good way here. So this is a tweet from Andrew Karpathy, which is one of the founding members of OpenAI. In numbers, there's probably going to be significantly more AI engineers than there are machine learning engineers. One can be quite successful in this role without ever training anything. So think about all that. So how to do it? First up, let's get the basic down. AI is a big umbrella that fetch that makes machines act like they have a brain. Machine learning is a part of AI where computers learn from data. So instead of telling them every step, they get better at their task by themselves, learning from examples. Large language models, such as GPT, are special tools under machine learning focused on understanding and creating text. They can generate new text and images based on their training. So understanding these basics help us to see what AI can do and give us a starting point for diving deeper into the world of AI engineering. Next, let's talk about working with AI APIs. With APIs, we can ask these AI systems to do tasks for us. So some of the big names in the space include OpenAI with GPTs, Anthropic with Claude, Google with Gemini, and Hugging Face, which offer open source AI models. It's like the GitHub for AI. So first, try using and playing with these APIs to see what you can create or improve in your projects. So it's not just about using them, but understanding how they can change the way we build software. And that's a big thing in AI. The code is not very complicated, to be honest. But there is a lot of tools and things, and the information is spread everywhere. And it's understanding the ecosystem and what you can do, and then you want to dig and learn things. So experimenting with these AI APIs can open up new possibilities for your projects and products. Next, you need to understand RAGs. So who knows what RAGs are? Okay, not a lot of people. So RAGs means retrieval augmented generation. So with RAGs, we can augment the model with additional data. So the model is trained with all the internet, etc. But for example, if you're building a customer service chat for your company, you will first need to feed the model with information about your company. So this will augment the model, and then the AI can generate information to people who are chatting with it. So next, let's see how we add this data, this RAG, to the LLM, and how we retrieve the information. So first, this information needs to be broken in chunks, because the LLM have a limited number of tokens. You know, when you are making a chat with ChatGPT, if you make a very long chat, ChatGPT will not remember the first your first question, etc., because it don't have enough tokens to digest all this content. So we need to broke this information in chunks. Then, depending on the question, on the query, they will find the corresponding chunk semantically similar. This means we can ask AI to find pieces of text that are not just similar in words, like in classic search, but in meaning and context. That's a semantically similar thing. And then it will apply this chunk as context for your query. Then these chunks need to be transformed in embeddings, which involves converting this data into vectors. And vectors are array of numbers that the machine can understand. Then these vectors will be stored in a vector database, and there is many existing databases that have a vector option, for example, Supabase. Then the query will also be transformed in a vector, and will search the database by semantic similarity in order to generate responses based on the most similar context. So imagine you have a chat about recipes, you have all sorts of recipes, and your query will be, okay, find me recipes for summer. So it will return recipes that are light and fresh, like salads, not soups, because it will understand that summer is hot, so you need fresh and light food, and so by similarity, you will present salads or other foods that are fresh and light. Even in the word summer, there is not the word salad. So this is how it works, basically. So here is an image. We have our users that enter a question, a query in the chat. This query is sent to the embedder. Then these embeddings are transformed in vectors and sent to the vector storage and sent to the large language model. Same thing for the, I don't know this word. Oh shit. I don't know. Okay, and then the data source is also sent to the embedder and to the vector storage and to the LLM, and with all that, it retrieves the right chunk, which is similar, and generate the answer. So that's nice, but if you build real-world AI application, it will not only be a prompt to an LLM. You will need several tasks. Imagine that you build an app to plan vacations. It will need to understand user preferences, to find destination, to check the weather, so you have to call a weather API, to suggest travel options, etc. So this is where orchestration frameworks like LangChain or Llama Index come into play. They help us to chain different tasks together, as well as methods to chunk, retrieve, embed, generate, etc. And also to streamline the work with different LLM APIs, because for different tasks you have to choose which LLM is the best, because you want to spare tokens, because it becomes costly for tokens, so you are not going to use GPT-4, which is expensive for everything. And also, yes, you can use a tool named Flowise. It's a graphic user interface. It's no code, and it's on top of LangChain. LangChain, by the way, is in Python, but it's also in JavaScript. So I'm looking a bit of Python, which is not very complicated, but it's in JavaScript. And so Flowise, it's a graphic user interface, and you can build your application visually, and it delivers an API. So I begin with that, and then it opens your mind to understand what you can do and what can work, and then you can dive into code after. And finally, I have my hands on the beta version of a very promising developer tool named Langbase that will be released this month. And with it, you can create what is called pipes, which means prompt instruction personalization engine. And these are like AI features, like you can deploy like a serverless function, leveraging any large language model, tools or knowledge, and then you can share them and reuse them. And all that is done through a sleek graphic user interface, and you can upload your data to make RAGs and also optimize the tokens. So take a look on that because I think it will be very nice. So, in conclusion, natural language is emerging as a new tool for our trade. But let's not forget, the essence of being a developer cannot be replicated by AI. Our ability to understand deeply, innovate bravely, and solve problems creatively is what makes us uniquely human. So as we embrace AI, remember that is not a replacement, but a supplement to our human capabilities. So let's continue to push the boundaries of what's possible by learning to code along with AI, as well as learning how to build powerful applications with it. AI can support us in becoming the best developers we can be. So here are all the links, if you want to take a screenshot, that I have talked about. And then there is another thing just for the slides. So here you have this QR code for the slides. And thank you, and please, if you have questions, find me outside. I love talking with people. I'm a people person, and I'm very interested about AI, so don't hesitate to talk to me.
Yes, we're going to have an hour break in this room, so we'll be back here at 3 or 5.
Luca, come as well. I'm a micro-frontend sandwich. Can I have some? Can I have some? Hello? Oh. Thank you. Hello? Hello? How's it going so far? Good. Do we succeed in this room? Please no. No? Okay. So yeah, this is, I discovered Zach, I think, because of Luca, because he was doing Micro-frontends. Surprised. Yes, quite surprised. And I was quite interested to find out more about it. And the story is that 2 years ago, I was, I wanted to do something between micro-frontend, server-side stuff, and I had this idea that we should load the module federation on the with SSR. So I spent I was on holiday, and I had to do a talk in a conference for Alicante. And I have been contacting different people, but I left Zach for the end. So while I was on holiday, I was making this kind of course at 5 o'clock in the morning when I was in Greece with Zach. He explained to me how module federation works. And in the morning, I was waking up like 2 or 3 o'clock because I was spending it was a really late night during the time difference. But every time I was talking to him, it was like my mind was blown. So for the stuff that he does. And last year he came to the conference for the first time, and he gave a talk. He told us about some changes. Right? It was about an announcement with Angular, correct?
Yes. Yeah.
And this is good. I'm doing like an introduction, and more people are coming in. It's great. And this year, he has to do another announcement, right?
Of course, it's the tradition.
It's a CityJS tradition. Not transition, it's transition to something else. So that's what you're going to find all about. So yeah, with further ado, we have the creator of Module Federation in our conference. I'm very honored. And two micro-frontend gurus here in this room. So yeah, enjoy.
We have 3.
And we have 3, yes, 3. And I already persuaded one of them to come to Greece. So he's coming to Greece and he's doing an Angular micro-frontends workshop. So yeah, if you want to come along, let me know. But yeah, maybe these 2 guys will come as well at some point. So enjoy. Zach, it's all yours.
All right.
Thank you.
Thank you. All right. Well, thank you for coming to this talk. For some quick context, raise your hands if you're not familiar with Module Federation or know what it is. Okay, wow. I'm impressed by the amount of people who didn't raise their hands. Okay, it's actually getting popular now. Okay. All right, so for those who don't know, the general idea behind Federation was when you work on a front-end code base, generally you're working with a monolith. And if anybody's worked with a monolith, at some point it stops working. Usually how you try to break the problem up is something like an NPM package or maybe a monorepo. If you want kind of independent delivery, you're probably leaning toward NPM package publishing. The big challenge that always comes with this, though, is it's really hard to scale. And you kind of get into this like double deploy hell where you want to update button, you have to release it, you have to turn around, install button into header, release header, turn around and install header into your application, and you're finally there. So there's a lot of friction in the flow. So anyway, I tried to set out to solve that. And so my solution to it was federation. The main goals of it were, something that offers autonomy, minimal UX drawbacks, and something that's, relatively simple to work with. And something that can ideally try to recycle code. I think big thing in micro-frontends, maybe before 2019, this was a really big challenge. You could do it, but it was kind of like the butt of every joke, micro-frontends, because it was super wasteful, very inefficient. So a big thing I really wanted to do was to be able to actually share dependencies and share code and recycle what's already available that will work. And so federation came along. Federation doesn't just work in the browser. I have seen it in game consoles. I have seen it in cars. I have seen it in drones, Electron apps. Pretty much everywhere I've seen it run. Obviously, server-side node, it works as well. So it's really nice that you actually have a solution for distributing and consuming code that works anywhere that JavaScript is capable of executing. And it's been about 4 years since Federation was released. And in that time, we've gotten a decent user base. We'll see a general trend that showed up, which is kind of what it was designed for. And that was leaning toward the larger companies where the problem of scale, really starts to implode and there's not much choice to fix it. So, what I found quite interesting was 30% of Fortune 50 companies are powered by Federation. So I've always been really impressed by that. And, we've got, almost 500,000 companies or sites that we're tracking that currently implement the technology. So it's grown. But it's also time for redesign. So when it was originally designed, what I kind of wanted was code splitting between different builds. That was the general idea, or that's what I thought we needed at the time. But a couple years in and lots of user feedback, many workarounds and hacks, we started to realize, and also just 4 years into it, architecture has changed, the demand has changed, how we're building these applications has grown more complicated. And what Federation was originally built to do still does it fine, but it's not necessarily strong enough to the end user to enable your really complicated scenarios. So what I thought I needed was dynamic import between bundles, and kind of what I actually wanted or needed is express middleware on your import chain. And so anyway, so we kind of, and also, new bundlers are coming into the picture now. Webpack is still a great API, but, it's losing a little favor because of speed concerns and probably one of the biggest things that kind of weighed Federation down was this kind of concept of the lock-in to a bundler. So, we wanted to try and address that. So let's rewind 12 months. So 12 months ago, I was on stage at CityJS. And I had maybe a week before, I came across this new compiler that was just out. And it was called RSPack. And what was really neat about RSPack, because I'm a big Webpack enthusiast and loyalist, probably defended it for a lot longer than a lot of others have when it started to fall out of favor. But I really couldn't find something that could replace the strength of Webpack's API. So for me, it was always worth the trade-off. I always think of a bundler as kind of like a workhorse. I don't need it to go quickly, but that's nice. But I really, really need it to be strong. So anyway, RSPack kind of came out. And the whole idea with RSPack is it's Webpack written in Rust. Everything works, So that was really cool. And this is, again, 12 months ago. This thing just showed up on the radar. And I kind of announced it, or the first kind of speaking about it was here at CityJS on stage. And actually, after that conference talk, I got a message from the team that built it saying, hey, do you want to come work here? So guess where I work now? So let's go back 9 months. I start working at this company, and I find out that it's a ByteDance, by the way. And I found out that ByteDance is actually the largest user of Federation that I have ever seen or heard of. So another great win. And what we ended up seeing is a lot of investment into the technology. So what we ended up doing is unifying our internal infrastructure team and our resources into the Federation layer. And this has been really great. And that was about 9 months ago where we announced we're going to start doing that. 4 months ago, the crab gets the gauntlet. So Federation rolls into RSPack, and it's got pretty much all the support that you would expect from Federation. But when we did that, like I said, still need a bit of a redesign here. So there's a couple extra things that it comes with now. So the big thing that I really, really love is look at the speed differences there. So on the one side, we have an RSPack build, and on the other side, we have a Webpack build. They use pretty much the same Webpack style configuration, all the same loaders, but the speed difference is pretty dramatic. We're seeing average builds there of around 200 milliseconds, but on the Webpack end, you're seeing 2 to 4 seconds in your build. And this is generally what you would see. So if you do use Webpack or something like that, it's mostly a drop-in replacement if you did want to switch. And the general rule of thumb we expect to always see is a straight 10 times improvement on compile speed. If your build takes 40 minutes, it'll take 4 minutes. Easy math. So let's see. All right, so then we came out with something called Module Federation Enhanced. The idea behind it was a major rewrite, introduce hooks and an SDK, and again, with RSPack's introduction, we needed an effective way to decouple it from Webpack. To do the decouple, though, I was also trying to think about more bundlers, the future of this, and not kind of repeat the design that I had implemented into Webpack. So with how we redesigned Federation, we kind of ensured that it operated more like SingleSpot would. It's a runtime library that the bundlers can implement. And this is really great because it means that I can centrally maintain Federation in the Rust side and in the Webpack side and in any other bundler that we pull it into, and I don't need to recompile, say, RSPack in order to upgrade, change, or continue to modify Federation. All right, so the first thing we added was this runtime API. So this is kind of the nice thing about it. If you don't even need the Webpack or RSPack Federation plugin to utilize Module Federation anymore, since all they do is pass some data from their build into the runtime and initialize my runtime. You can also just use the runtime. So this is quite nice because before there were a lot of hacks on how you could, like, say, dynamically load a remote. Sometimes you statically define them, but what if you don't know what you're defining, or user configs influence it, or white labeling, A/B testing, all of these things? It became really tricky to dynamically load them. And so pretty much we've introduced, the same style of configuration that you would get from our runtime layer. We also have this, the same kind of thing if you want to share code. So consuming code, sharing code, looks very similar to how the plugin operates. And you can, use load share to centrally resolve React and not, pull it in multiple times. So same mechanism, but you don't necessarily have to be hooked to a bundler to do it. Then this is probably the best piece that we've rolled out so far, and that's this concept of runtime plugins. So Federation really gives us the ability to import code from any other bundle and only import what we don't already have. This sounds really great in theory until you spend a couple of years scaling it up, and then you realize there's a lot of challenges. You need some kind of life cycle to control it. Similar to how React has a life cycle, dependency loading, you kind of want some life cycle on it. What if a remote isn't online? What if there's a weirdness with package resolution and you want to share code, but you have one problematic code base that can't just utilize a single instance of it, or needs an older version that might break the rules of the rest of the system? Tons of things where you kind of want that middleware life cycle, where within context of what's happening between the provider or the consumer, you want to control that relationship. And that's where the runtime plugins come into play. The big thing we introduced was this idea of a four-way handshake. So the idea here is, in the first version of Federation, the thing being consumed has no control over how it's consumed. And this is quite problematic because you couldn't say reject being consumed or put auth around your module loading or A/B test it. Anything you had to do it in the consumer end. And that kind of breaks the rules of micro front end, where if I have to go here and tell it how to consume it, then what's the point in providing it? So the four-way handshake means that this lifecycle will run in your host or the one consuming it, but the same lifecycle will also run in the remote. So the remote knows where it is. Who is busy calling my import? Who is asking for something from me? Are they allowed to consume me? All of these type of things, and you can choose to reject being consumed. And because of the context layer there, similar to like React context, you could say, well, I'm going to import header everywhere, and that's just a static import. But depending on who's importing header, I can change what's being imported. Or depending on the region that this is being loaded, you can again change what your import actually means. And you can do this, relationally, you can do it globally. There's many ways that you can kind of take advantage of these life cycles. And we have many more on the way, but generally, this is a good spread of what to expect. So some examples of how to use this, which is really nice, is, in this example, I'm going to switch out Lodash. And I'm going to now change React DOM, and I'm going to tell it actually override the rules, and I want to use React 16. So app 1 is now using 16, which is originally vended from app 2. And even though my demo is a little messed up, because it should show the used ends there, but clearly my code is not great. But you can see on some of them, I can actually see which applications are depending on these versions and what they're currently using or what the overrides are and things like that. And this is all just from in-memory within the federation layer itself. We also have, offline remote, which has been a major problem. I've heard about this issue for years. If the container or the little layer that you connect to cannot be reached, it's very hard to catch it. You could maybe sometimes use like a dynamic import, but the dynamic import won't work if, say, the whole container isn't available. It'll cause like a hard crash inside a Webpack. So it wasn't necessarily completely resilient. And if you use import from, then it's game over if something goes wrong. So using the new runtime API, we can write a little runtime plugin that can handle offline remotes. So I have two apps here, and one of them is not online. And instead of it crashing, it just tells me, hey, couldn't get it, and that's the reason. So what would the runtime plugin look like for that? That's pretty much it. Error load remote, get whatever you want, which you can see in my error message is just a little like JSX-y message that just pulls the data out of the plugin. And you could have this thing do a dynamic import and load another component if you're offline, fall back to NPM, or you can just refire the whole life cycle and say, hey, well, you errored, so now the offline remote is origin number 2, and rerun the life cycle. And if origin 2 is offline, it'll just loop until it finds a success or until you bail out of it. So another nice one is the concept of API-controlled remote configs. So a lot of people have wanted this dynamic control or ways to kind of change this based on what's happening. And this is a very rudimentary one, but essentially I click the button and it's swapping a new container in there. And I don't have to have these all hard-coded, and I don't have the logic written to say, oh, well, when I click this, import from app 3. It's just import app 2 button, and every time I click it, the kind of middleware layer of federation is swapping the dependency layers out for you. So basically what that means is import from some string has no real, recollection or no real importance. And this is kind of what that custom plugin looks like to write. I'm using local storage right now, and I have an override map or whatever, very basic, but that's essentially what it does. And this is what it would look like to implement. Normal federation config, URLs that don't go anywhere, and I've got my runtime plugin that I kind of set. And again, import maps, can rewire them to where they go. You don't need to know them up front. You can put whatever there, and you can kind of rebind them as you want. So some new features we've brought in as well. Big request has been TypeScript support. And we finally have it. That's the remote. That's the consumer, and there are the types, and It's already there. So you've got hot reloadable, distributed TypeScript definitions. This works with third parties. This works all the way down the nested chain. And if you just use the Federation enhanced package, it just works out the box. Nothing to configure. Maybe one thing you add to your TS config. We also finally have fast refresh and real hot module reloading. So I did this yesterday just to make sure it works, but type whatever you want in there, and you'll notice this is not live reload, but it's actually real fast refresh. And these are, again, multiple apps. It'll work nested, typically how a normal monolith would work, same experience now. So I'm very thrilled to have this one working. We have also introduced the concept of runtime lock files. So lock files are a big one. Federation is not very deterministic. If you ask for React, you will get a React in that version. But you can't specify, I want React from over here. So caching is a little bit tricky to deal with and so on. But you can see we support API endpoints or JSONs that you can use instead of the JS file. From there, we can do a whole bunch of stuff. But essentially, I can now point this to an API or something like that, and I can pull back a manifest that instructs it what to do. In this case, our edge worker looks something like that. We pull our manifests for production, and we can calculate what Federation is going to do with the generate snapshot from manifest. So our production environments are that calculation. If we change the database value, production changes. And it never deviates from whatever that lock file says. Always works the same way every time. And that's how you would implement that manifest. Use a runtime helper in the runtime plugin, and we just bind it to, a snapshot. And we have something in the layer that knows how to look at it. We have also got Chrome DevTools now. So seeing what's going on isn't a nightmare. You can override them with the module proxy, which is great. Using those manifest URLs, you can see who's using what and where, what they vend, all of that. And you can also, when you populate those, you can hot reload these in any environment. So if you're in production and you want to debug a staging header, Chrome extension swaps it out wherever you want. We also put out new docs. It's been a busy year. The new docs are still a work in progress, but if you want to find out what's going on, this is where you can kind of go to find it. And another big one I think we've all seen is the deploying and management of these things probably gets a little tricky, especially as you start to scale it up. And it was definitely hard, or it was hard. But inside of ByteDance, we have something called VMOC. And the scale of how we use Federation at ByteDance is quite significant. Thousands of deploys a day, tens of thousands of engineers, tens of thousands of repos, and I think every remote has thousands of versions on it. So distributing this everywhere and managing it at a tremendous scale can get quite tricky. But unfortunately, it's an internal tool only. And we really need this for, be nice if it was solved. But after looking, and this is what our VMOC looks like internally. So that's how we kind of manage all these things. But it'd be real great if there was something that others could actually use. So I was definitely inspired by what we have internally. And so we decided to take a project that I had called Medusa and give it a rework. So this is what Zephyr looks like. We've got our little side panel in here. These are all the individual remotes or containers that we've got. This is, the typical tractor one. You can see the remotes that we're pinning for which version and so on. And the nice thing about Zephyr here is you don't need any Git, you don't need any CI. If you build it locally, it is already deployed. The only thing stopping you from using that code in production is any artificial limits you choose to impose. But from a delivery and distribution standpoint, most compiles are ready to be consumed in real user traffic in under 10 seconds. Setting up Zephyr in an existing app or something like that, Jack Harrington has a Create MF app, CLI, which is quite nice, so we tried that out. And it takes less than 60 seconds to go from new repo to looking at it in production, and you've torn down your local instance, and it's already available. What's really interesting here is you can see we've got tags, obviously, and build versions. We record every build version that's available. The nice thing about Zephyr as well is it is bring your own cloud. So we don't mark up any hosting costs because we don't want to host your stuff. We just want to manage your hosting. So if you use AWS, Netlify, Cloudflare, whatever your provider is, it all stays in your VPC. Kind of like Kubernetes for the front end. And the nice thing as well, it also hot reloads. Anytime you change a version, the environment will change and it will show up. What's really interesting is we've seen, when we were developing on this, we have someone working on the header remote, somebody working on the page remote, and whenever one of us makes the change, it's all unified, and we're seeing everybody from around the world who's working on this, and the updates are coming in live on the spot into it. So you can actually have multiple people work on the same project, and you don't need to push and pull and synchronize things back and forth the whole time. It also has visualizations, which are nice, and things like that. Let's see, so a very basic example here. Again, I've got hello world, I open up my side panel, and I choose that, and hello CityJS, and that's effectively it. If I push publish update, that's my deployment. And that's really it. That's what our production deploy looks like if you wanted it to. We also have unmanaged remotes. So even if you're not using Zephyr, you can use its intelligence engine, sort of, to control and manage all of this stuff. And if you do want to check it out or sign up for it, it's in Alpha 1 at the moment, but Zephyr Cloud IO, or you can grab the QR code for it. All right, I know I don't have much time left, so just a little bit more. So if you do want to see that Create MF app one, which is like 60 seconds and you're in prod, there it is, and the instructions for it, pretty easy to kind of get up and going. All right, so last little bit here. Federation's great, but the family has grown a little bit. And this is what the family looks like now on our infrastructure team. And you'll see a lot of crab guys here. These are all variants or products built on top of RSPack. We also have OXC, which is our kind of like SWC, but it's extremely fast. So fast that if you use OXC lint, you can lint your entire file system in, I think it was 4 seconds. So it's pretty quick, millions of files. We also have modern.js and a couple others, but I'll quickly get into them. So we have RSPack, which is just Webpack written in Rust. What's quite nice about RSPack is, generally it's drop-in. Currently, we are 76% of Webpack's API. All their ecosystem tests pass, and that's where we're sitting. I believe by June or July, we will hit the 90 percentile or the V1 range, and we'll kind of start going beyond just catching up. I have this in twice for some reason. All right, so speed-wise, like I said, it's significantly faster. You're looking at 10 times the speed. That's generally what you should see. We also have our modern.js solution here, which again, if you're looking for like a framework that's really friendly to micro-frontends, this is essentially like Remix, but for micro-frontends, and it uses a lot of the Remix stuff under the hood as well. So it's not another framework that you have to deal with. We have RS Doctor, which is pretty nice. So bundle analysis is hard, and there's not been much change in the space for a while. But finally, there is. So actually being able to see why things are the way they are, being able to see where your file sizes are coming from, who's using what, being able to actually diff it and see the code that's loading in here and how tree shaking is used or unused to actually know, are you tree shaking correctly? What's not getting shaken out? Actually seeing why things get slow. You can now see how long each plugin takes. You can see how long each loader takes, the resolve time for each loader, for each file. You can even see the diffs between them. When it does the resolver, what did it resolve and why? And you can also see the loader chain to know exactly where all of your speed has gone. And this works for Webpack or RSPack, which is quite nice. We also have RSPress, which is what all of our docs are based on, basically static site generation style, but built on the Rust toolchain with a lot of things built in, so you don't really have to look around for cobbling together solutions. And oops, and yeah, modern's already in there. So a little bit on our roadmap. So we've already got some of this family in here. We are working on something called RSlib. Pretty much what we've done is we've partnered up with Webpack since we have a lot of things in common. And we're working, I think, at the Google Summer of Code I think it's in Norway. But we've come together to decide what do we want to improve, because we don't just want to improve RSPack and kind of not really pay our dues. So we collaborate quite a bit with them. One of the big things that we're working on with them is import map support. So actually getting a Webpack build, RSPack build that can do import maps. RSlib is going to pretty much be RSPack driven solution for package building. If you've ever built Webpack and you try to use NPM, like build an NPM package, you lose your tree shaking or it doesn't work well with CSS. There's a bunch of other problems. So we're going to try and solve that so everything works kind of the way that you want. And we're taking a little bit out of TurboPack here with their multiple output targets or parcel. And we want to make it so one build can output RSC, CommonJS, ESM, browser, service worker, and you don't need like 4 compiles to do it. In modern JS, we're going to be bringing in Node and SSR support. And we will have 2 major OSS things getting added, but I can't really speak about them just yet. But stay tuned. So anyway, really high level, really quick, but thank you for joining this. And if you do have any questions and you can't catch me now, I'll be around and I'm happy to chat.
Okay, so I've been trying to keep these books away, and I think because we're doing module federation, and we have the person that wrote the best select for Micro-frontends here, and he happened to be here, so sorry. So, Zach, I want you to be the one that is going to decide who wins. So you need to press my laptop.
Press Control Enter?
No, just press the
okay.
mouse in the wheel. doing an Angular, Angular.js, and it was really great. It was before React was quite strong, wasn't it?
Yes. I started in Angular 2.
You started Angular too?
Yes. So.
Yeah, so I started when it was Angular.js, and then React picked up, but now Angular is coming back, right?
Yes, the Angular Renaissance is a thing, apparently.
So, we had this conversation that you want to do like an AI talk, but
Yes.
I told you, Angular is getting stronger. I want to hear about Angular, right?
It's true. I was able to weave it in a little bit. So I have a mic.
Oh, you have?
Yeah.
She has a mic. This lady is very advanced, okay? She's advanced as Angular. Hey, okay, so here you go. Let's do it.
Okay. Thanks everyone for coming. All right, I'm excited. As all speakers do, they procrastinate and wait till the last minute to write their entire talk. So I was able to finish it yesterday, which felt pretty nice, around 2 in the morning. But we're gonna talk about the new Angular today. And this is a very pretty color scheme, isn't it? I tried to make my presentation match. And what's funny though is it's RxJS colors. So today we're going to be talking about a few things. We're going to be talking about the new docs, Material 3, the control flow syntax, signals, deferrable views, and server-side rendering. I'm going to probably focus a little bit more on the Material 3 and signals aspect of things, but it's exciting. And Manfred, you can tell me all the things I'm doing wrong after this talk. I didn't run this by Manfred. So my name's Tracy. You can follow me on Twitter at LadyLee or on LinkedIn at Tracy S. Lee. I'm the CEO of a company called ThisDot. We are hiring. I'll go here first. 100% remote global team. We have 2 folks in the UK right now, one in Swansea and one a 2-hour train ride from here. I don't know where he lives, but he says it's 2 hours. So we're looking for senior project leads and architects. So email me, jobs@ThisDot. If you are looking as well. I'm on the RxJS core team, Google developer expert for Angular, Microsoft MVP, and generally, love to support the community. So let's just talk about the new docs really quickly. You can't, if you Google Angular docs, you don't get angular.dev, but you can go to angular.dev, and they're trying to create this new experience of learning Angular. So I would definitely check that out. Material is, what, did I miss a slide? I don't know. But anyways, point being, Material 3 is something that was introduced experimental in Angular 17.2. It is backwards compatible with Material 2. For those of you who don't know, Material 3 was actually introduced in 2021, but I feel like we're all still dealing with the pandemic. So did I miss that? Yes, I did. But now you can actually just stick it in your app. So again, Material 2, Material 3, that's kind of what it looks like, the comparison. Another little comparison here, and kind of bigger, more emphasized, so new web. And you can see these new buttons. So the last talk, I noticed that it was actually Material 2 still. But you can use Material 3 now. I wanted to show you guys just kind of how easy it is to do this. So I built this little app, and this is what I spent way too much time on. How many of you heard of the RAG stack? Retrieval Augmented Generation. So anyways, I built a little Angular GPT that will talk to you, but the point, I'll go through that a little bit later. But the point here is that this is Material 2, right? You see the buttons, and it's backwards compatible, right? So Material 3, adding it to your app is backwards compatible. Let me go to my code here really quickly, and I'll just comment out a few things, or comment back in a few things, actually. So what you need to do is you need to make sure you're importing it, npm install Angular Material Experimental, and then you're just basically, I'm keeping all my Material 2 stuff in here, but I'm just defining a theme over here, and it's different colors as well. So, I'm choosing the yellow palette here. I'm gonna save that and make sure my app doesn't break. And then I'm just including things over here. So again, just a few lines of code you can see that make it really, really easy to, boom, there we go. So I really didn't have to do that much, right? I mean, I just edited a little bit of Sass, and here we go, Material 3. So now we have a pretty little app here. So anyways, again, I would highly recommend you guys checking it out and looking at how to upgrade to Material 3 in your applications. The declarative control flow syntax. This is pretty exciting. I think things that are exciting about it is you can just kind of write if, else, else if, for switch, everything like that, just directly in your app. So you don't have to do so much, ng switch, ng if, et cetera, less code switching, so just making it a lot easier for us. I don't know about you all, but as Angular developers, sometimes I'm like, did I import that? Did I put that in my, in my TypeScript file? Did I not? Angular, again, the team making it really, really easy for us to migrate over. So you can just migrate over your entire app with ng generate Angular with the core control flow, or you can migrate a specific file as well. So again, making it really, really easy for you. If you guys haven't seen it, this is kind of what it looked like before with the ng switch and switch cases. And this is kind of what it looks like now with the switch and the case. It's so hard not to like turn your back on you all and look at your own slides, right? It's such a bad habit, but here we are. So that's kind of what it looks like. And then I just kind of want to show you guys where I use it in my app so you can kind of get an idea. Where is my, here we go. So you can see now in my template, I just can say if and else, and it just works. Life is amazing. So I would highly recommend you guys kind of checking that out and starting to use it. Signals. So being on the RxJS core team and having Ben Lesh be one of my best friends, you got a little worked up when I brought this up. So signals, I think it was really confusing when this was introduced because we talked about adding reactivity to your app, so everybody thought it was like this replacement to RxJS. I don't know if some of you all think that right now, but it is not. So signals are amazing because they just allow you to know when something has changed within your app. So you're reacting to completion of operations like API calls, and you can just update the UI. I'll show you guys that in my app in a second. Managing user input, right? Just updating the UI based on user interactions, and just coordinating data flow. So Ben, I got off the phone with Ben the other day, and then he wrote this really long Twitter thread about signals versus observables. So if you would like to argue on the internet, you can also find this thread and argue with him on the internet as well. But I also made this pretty slide kind of summarizing observables versus signals. So when you think about observables, right, they're just functions. So composable functions with guarantees. You should be using observables for cancellation and event coordination. Previously before signals, and probably now anyways, I would see a lot of people who are going through large app migrations, and they would just stick everything in RxJS, and then, kind of stick all their state in RxJS and then kind of migrate their app that way. But now you should use signals if you're doing that with Angular. Observables are generally state, sorry, let me explain signals. Signals, basically it's a dependency graph of values and logic around notification, invalidation, computation, memoization. Ben's actually working on, with the standards bodies as well, kind of trying to get it into, did it land in Chrome yet? Is it behind a flag in Chrome? Nobody knows signals? No? It's either there or almost there, but signals are going to be like native to the browser soon, which is going to be amazing for all of us. Observables, generally stateless. You process an event, it cleans up. Signals maintain state, they retain things in memory. Observables, when you think about observables, multiple values, a collection of events and values over time. Signals, single value, and it's a value that changes over time. With observables, you can push n values. Signals, you can read one value. Converting, so there's this like 2 signal and 2 observable in Angular, which I think is also kind of confusing because you think they're interchangeable, which, I mean, but you can actually, with observables, you can convert it to a signal. With signals, typically you're not wanting to convert it to an observable. It's typically avoidable because the event that set the signal can also like notify the observable. So next slide. Okay, so there's been a lot of like people talking about signals and implementing in their apps and, trying to figure out better ways for us to do as developers. Tim does some amazing stuff in the Angular community, and he has this signal forms. So, there's many ways, again, to implement signals within your application, but you should definitely check this out. It's kind of cool. But I will also show it to you in my app really quickly. So if I go to here, you'll actually see I have 4 signals: thinking, question, response, data, and response. These are all just regular signals, right? And then this is a computed signal. And let me just explain to you what the app is, because that's probably important as well. This is just an app that, again, the RAG stack. So it uses OpenAI's API, and it's going to return responses from OpenAI for me. And you can see that kind of over here that I'm using GPT 3.5. And then the other thing I'm doing, so RAG stack is like this AI thing, a retrieval augmented generation, and that's the G, generation, you're using OpenAI. The A is augmenting, so here I'm telling ChatGPT that they are an AI assistant, that's an Angular superfan, and saying, hey, make sure don't return any images, and format responses using Markdown. The R part, the retrieval part, is actually creating this little script right here, and taking all the new things about Angular, right? Because as we all know, ChatGPT doesn't even know Angular 17 exists, for example. But I basically took all this information on the web about Angular 17 and stuck it into, created vectors using Cohere's API, and then stuck it into a Astro DB. It's a vector database. That's from DataStax. And now the app knows about Angular, which is really exciting. Let me see. Let me go back to my app component right here. So anyways, if I run this, for example, I can just say, and you can see it's thinking right here. That's using signals, and then it'll basically tell me what it is. And you see it knows about Angular 17. So that's exciting. But anyways, going back to the signals, I'm using the signals right here. And then I'm going into my app component, and you can see right here, I'm just using that if else that I showed you guys already. But as I asked it a question, you can see, right, it'll say it's thinking. And then once it's done thinking over this conference Wi-Fi, it'll tell me different things. I like this. I know this is like you can actually tell ChatGPT to talk like a Valley girl, and then it will actually start doing that. So it's fun to play with. If you all haven't played with these new APIs and things like that, you should definitely check them out, because, you can entertain yourself. So you can see, it talks like a Valley girl right there. But, I think this example right here, right, is, I'm not doing forms. Right, here's my form right here. I'm not doing it kind of like the way, I don't know, I don't want to say the Angular way, but I'm just using signals, and it just kind of works, right? So signals are really great if you just want to add a little bit of that reactivity to your app without having to do a lot of stuff around it. And you can use it with as well. And again, there's a lot of documentation on the internet kind of talking about this, but it's pretty cool, and I like the new syntax as well. So deferrable views. Anybody excited about deferrable views? We're just talking about this. Deferrable views. How many of y'all know about islands as well? Islands is yeah. Or quick, right? Misha goes over at quick now. But I don't want to say they're all doing the same thing, but they're all kind of doing the same thing. Is that a hot take? Depends on who you ask, okay? But all kind of trying to accomplish the same thing. I'll talk to you a little about deferrable views. So you can basically just lazy load components, directives, and pipes into a section of your template. It reduces the initial bundle size, which I think is really awesome. It has these built-in triggers, prefetching also, less boilerplate. I feel like Manfred used to talk about lazy loading a lot, right? Didn't you talk about lazy loading a lot? No? I just love, you guys probably heard Manfred talk. I love his accent and how he talks about Angular. It always excites me. But I just remember in my head you saying lazy loading. So anyways, but you can see also, the deferrable views. So defer, it just uses kind of the same syntax as well, and just, again, makes it really, really easy for you to make your app more performant. Yay. server-side rendering as well. So there's nothing too new about this because, we've been talking about this for a while in Angular, but there are a few updates. We're saying goodbye to Angular Universal. And so now it's directly integrated into Angular CLI, so you can just ng add Angular/SSR, and you can also automatically update with ng update, which is nice. Vite and ES build, they've been messing around with that since I think 16. I could be wrong, don't quote me on that. But if you read Minko's blog post, there's been a lot of build time improvement. So they just made it default now. And with SSR and SSG, if you use it, you can actually observe up to 87% speed improvement, which is yay. And the new docs, angular.dev, actually have an entire guide on SSR if you want to check that out as well. So talked about a few things. Hopefully, I think the biggest takeaway here, the two things that I get more excited about are material being so easy to add to your app, and also signals and kind of helping people understand better what signals versus observables is within your different apps. Let's hang out. You can, we do a lot of content on this.so you can find us at this.co. I'm doing interviews today with engineering leaders. So if you have an engineering manager up title, come hang out with me and do a 10-minute interview with me. You can find me on Twitter at LadyLead as well, or on LinkedIn. And that's it.
You have been doing some great stuff with this dot and some podcasts and stuff.
Yes.
You be talking. How do the people get to that?
Well, we have two podcasts actually run by this dot. There's the Modern Web podcast, which we've been recording here as well, and then we also have the Engineering Leadership podcast. So if you want to learn the latest, greatest stuff, I do that with Ben Lush and Adam Rakis. It's a weekly podcast on Modern Web, and then for the Engineering Leadership one. That's been pretty great as well, but just talking about how engineering leaders think. So that's always been fun.
What is the next big thing that you can reveal
The
for
next
us
big thing.
in
Well,
the podcast?
In the podcast?
Yeah.
I just did one with Elian and some other folks, right? Oh yeah. Is it being released this week? It's being released. Darcy just did one at some point in time with Ben and Adam as well.
You want to tell us a bit about it? You want to tell us a bit about it?
Yeah, we can speak about it.
Volt, a new package registry, right?
We'll play next with you.
But yeah, Darcy's doing some cool things, so you should all mob him too later on. But yeah, so yeah, really fun content there, and we're always happy to have more people come watch it.
Are you coming also to the pub?
Yes.
So if you want to find out more, you have to come to the pub.
Yeah.
It's in UK, so we go to the pub after.
Yeah. Or if you're interested in a job.
Yeah.
Company.
Oh, are you recruiting at the moment?
Yes, we are. Yes, we are hiring. Yeah. So we just hired I think 3 or 4 people, and we're hiring more.
I
So
mean, it is all remote jobs. Is it?
fully remote. Yes.
Fully remote. You don't have to go to the office.
Yes.
Yeah. Great stuff.
Yes. Awesome. Thank you.
Another big clap for Tracy. Okay, who is here up for Astro?
Let's see.
Club for alien, very alien, like
Alien.
another universe, right?
Yes, very much.
Can you
All right, thank you. Great introduction, Iris, thank you. Don't take him on the dancing, that's not happening. Well, ask me again after 10 beers. We'll see. So, hello everyone, I'm Elian. I work on this thing called Astro, which you might have heard of, but I'm also an organizer of a couple of things like React Brussels, BGS events, React Paris. Soon there is a new one to announce, but I keep that for them. And of course, I organize my own meetups in Belgium, in Ghent. I know anyone else from Belgium here? No? Sad. I was going to invite you, but it's fine. Okay, cool. Of course, you're not here for me. You're probably here for Astro. So what is Astro? Who knows Astro? Or at least has heard of it? Good, okay. Okay, that's nice. That's a lot of people. Good. Who has actually used Astro? A little hands went down. Okay, but it's still fine. Cool. So Astro is this content-driven website framework. Think of it like Nuxt or Next. It's a meta framework, as you will. But then with some cool twists and features and great developer experience. So this is a little bit of what the Astro syntax looks like. It's basically JSX, very recognizable if you've ever worked with something like React or just JSX-like frameworks. But you can use plain TypeScript in the front matter, which is the area at the top there. We call it front matter as of Markdown. Cool. This is actually real code. It's my website. Look how beautiful. I know not a lot of people like it, but actually you might not like it, but it is what peak app design looks like. Good. Simple code. But the twist is that we do it without any JavaScript by default. By default. So think of it like this. You have your typical page in something like React. All these components that you see here, like the header, the footer, is going to require JavaScript to render. Why? It doesn't need that because it's static components. So what we do at Astro by default is to compile everything down to just HTML and CSS, browsing native languages, that you can then hydrate later on. And because of that, we have like out-of-the-box Lighthouse score 100 everywhere. Well, now actually one has changed to INP or whatever it's called. I didn't adjust that yet. So that is ideal for content-driven websites. But of course, what if you need interactivity? Like we talked about it. Like, what if you actually need a button to actually have interactivity? Well, we have client directives. And client directives will decide how and when your component should become interactive and ship JavaScript to it, and how they behave. So we have a couple of those. I just listed a couple. I'll tell you a little bit about what they actually do. So we have client load, which will just mean, hey, I have a component, ship JavaScript to it as soon as you can. You have client idle, which will only ship the JavaScript as soon as the main browser thread is free. Makes sense. We have client media, it's a really cool one, that will actually only hydrate a component when a given media query is met. So for instance, you can say, hey, my button needs a little bit of JavaScript to be interactive, but only do it when you're on a mobile phone or mobile viewport. Now you have client only, which is basically, hey, I don't fucking care, do it, which is really good. So with the magic of those client directives, we can transform that same static MPA that we had earlier to an interactive MPA with a little bit of JavaScript where we just need it, nowhere else. The cool thing is that like the client hydration thing is totally, oh, I just noticed I have sound here. Yes. That will, you can totally build your own stuff. And what happens when you actually give developers some tools, they build stuff, and then they come up with things like this. Client when it's raining in New York. So this will hydrate your component whenever it's raining in New York. Yeah, cool one. So island architecture, that's actually the main thing that we talked about. Like Tracy talks about it as well. Islands is what we call that shipping the JavaScript to just that one component. It's an isolated component, it's an island in a sea of static things. So the cool thing is that on top of like all that JSX goodies I told you about, you can just use your own framework. Take Solid, take Vue, take Preact. You can all build it and place it upon Astro and just use that for your interactive components. And if you don't actually use that client, I'll show it in a second, but if you then actually don't use that client component there, then it will just simply return HTML, which is really cool. So you can build a full web app in React without actually shipping the React runtime. So what I'm going to do is just building a counter. So we probably all know how counters work, right? So I'm going to skip that. That's what a counter looks like. I think it's using, oh yeah, it's React, good. So if I place it here on the website, which is what I'm going to do here, is I import it in the front matter, because remember, that's the plain JavaScript, plain TypeScript, whatever you want. You can just use it there. And if you then go to the website itself, so localhost 4321, because liftoff, it will not work because there is no client hydration. And that's what we're going to add here. So we just go into that same counter component that we imported, add client, load, idle, whatever, raining in New York. And then you go back, npm build, preview. Why do I do the build and preview? Is to actually show you that there is no JavaScript being shipped to other stuff. Let's go. Preview, thank you. Yes, and there we go. So now when you click the component, you can see that it actually shipped that library to actually make it interactive. And all of these features combined make Astro so great and so fast, and maybe a perfect fit for your next project. And exactly like 1 year ago, well, it's about a year ago, it's actually 1 year and 1 month. I was, for the first time, at Vue.js Amsterdam. It was really nice. I was working at a cloud company back then, and I discovered Astro. Like, I needed it for very specific things. It was amazing. Like, it was mostly about like how to use it with cloud and stuff. It's really, really good. And the cool thing is, like, that was 1 year ago, and now Astro has turned 3 years old. It's basically a toddler that's crawling. How insane is that? Woo! Yeah. And just at that talk where I just showed you the picture of, like this one, that was actually when we just released Astro 2, and now we have Astro 3. And then we have a lot of memes like, hey, Astro ships a new one every minute. And it kind of is true, but we launched Astro 2, and Astro 2 was like a really great launch. We had cool stuff, like we built a new CLI, which is loved by a lot of people. And it looks like that, like it's with a cute Houston there. It's a really good CLI. And because we liked it so much, then we shipped, well, actually Nate did. I wasn't involved at all. Actually just built an open source library that you can actually use in your projects. And it's getting used like by a lot of projects now, which is really cool. And then we brought you content collections. And content collections are this way of working or like authoring content in Markdown or MDX that is completely type safe. And for that, we use a library called Zod. Probably you all know Zod, right? Yeah, good. And that will give you like an amazing experience once you're actually working with that data. You can just say, hey, I have a post, what is my data there? And then you can just say it has a timestamp, it has an author, it has this, it has that, and it's all type safe. Really great. We brought in hybrid rendering, and hybrid rendering is something that I think is underused still today. Hybrid is actually when you, for instance, you render your whole website statically just for one route that you want to do server-side rendering on. And why is that important? Well, you can actually improve the rendering performance of your popular pages, for instance, or just an API endpoint to an existing static website. It's really good. But also, we made a total new, like a makeover for our whole branding experience. And not just for our branding experience, but also for you as like the end user who actually uses Astro. We just ship amazing errors now. And they are very clear, like you can clearly see that here in the blog, there is an Astro tutorial.mdx and it doesn't have a title. Please add one. It's really great to see. Also, we shipped a new logo. It's this one. This is not the one, and that's still the one that people use, which is why. Then we launched Astro 3, so the next release, and the main thing was actually view transitions. Who has used view transitions before? Not too many. Good, okay, cool. Well, it's really interesting because actually these view transitions make your whole page feel like an SPA while it still is being an SPA. It's insanely good, and it all does it automatically in the browser itself, which is great. And the best thing about it, like in Astro itself then, it's only 2 lines of code to add it to all of your routes. It's insanely good. We also have image optimizing now, and image optimizing is really good because it will still, like you can upload your full asset and we will compile it down to WebP, and it will be like 5 kilobytes big. So all of that you don't have to think about as the developer. And that's of course all the stuff you want to see as the end user. Then we also shipped like the picture component. And the picture component is really great. Why? Because you can use different formats. You can say, hey, I want a WebP, I want, I think it's AVIF here as well. Like if you support AVIF, use AVIF. If not, then use WebP, like it's a fallback. It's really great. It does all of that for you. And then we started like refactoring our internals and got like huge performance gains. In comparison to like Astro 2, we are so much faster now. But one of the cool things about doing that refactoring is that we have something like React Refresh. Basically, your JSX state will stay the same. Because the thing is, and you probably all have had this issue before, is you're developing locally and you open a dialog, you change some text in the dialog and suddenly the whole state is gone again. That's so annoying. Well, with something like this, it won't happen. It just will stay there. It's really great. Page partials are also something really, really cool. It's basically like the most easy way to explain this. It will strip out the HTML and the head tag. It will just ship the line that you basically have in that component. It will do nothing else. Why is that good? Because you can use something like HTMX with Astro then to actually fetch your components and make it really great. Starlight. Who has heard of Starlight? Not too many, actually. Okay, interesting. Well, Starlight is this documentation framework that's new, built upon Astro, and like with content collections and everything that we have and support in Astro. It's a really great authoring experience for like documentation, and it's actually becoming a go-to for a lot of people, which is really cool to see. And of course, you can use all of the Astro goodies that you normally use, like image optimization and all of that stuff. It's still in there. And then, of course, our latest release we did not too long ago, actually. We launched Astro 4. And Astro 4, like one of the things I was really excited about is developer tooling. We're not as good as Nuxt, sorry, Daniel. But we have good tooling. Like you can inspect your islands, see what's going wrong. Do you have images, alt elements on your images? You can all see that right without leaving the browser, which is a good thing. So here you can see, like, audit it and then see, oh, wow, you have a missing attribute. And we'll run tests for you and check all of that for you. We actually have new ones now, like, for instance, misconfigured area attributes will also get flagged. And it's an open system, so everybody can, like, basically same as Nuxt, like you have the modules there. Well, you can also build your own stuff for the Astro developer toolbar. For instance, we have a really good one with Storyblock and a good one with Sentry that you can actually use all of it inside of the browser without actually leaving it. Something that I'm super excited about and is yet to be like released as stable is content collection caching, or incremental content caching, which is the same thing. Basically, it will, well, it does now, and it does make sense. Most of the things out there do it. Is actually when your code base grows, your complexity grows, your build CI gets way longer. But if you're just changing one line in one Markdown file, why rebuild everything again? So what we're going to do is then cache all of it and just rebuild that one page that you actually altered. And we did that on our own documentation, which is about like 3,000 pages of content and like 13 different languages. And it's insanely a lot. Like the build time is like 12 minutes or something. And then we saw an improvement, like with content collection caching enabled. It was an improvement of like 80%, which is insane. And then we also did our own documentation redesign because, of course, we had now launched Starlight. Starlight is stable. And of course, what's best thing, like build a tool with the tool you're building. So our documentation now is completely powered by Starlight. So all of the features that you see inside of our own documentation are available for you as well, which is really cool because that sometimes we extract something and make it a new library. For instance, we have Expressive Code and Lunaria. Lunaria is a tool to like manage all of your translations. And then we have Expressive Code, which is basically code block tooling. And it's really, really good. Of course, that's not everything. We have way, way more, but that will get too boring to explain. So what is next? That's the most asked question that I get. What is next for Astro? Well, the one thing I always say is, you decide. So we have an open roadmap. So right now, there are only 3 issues there. Make some, like, if you want to see a feature shipped in Astro, you just make a feature, and it might happen. But there is one thing I have not talked about today. And maybe you know, or you have seen it. It's called AstroDB. It's a database right inside of Astro. Well, it comes together with Astro Studio. And actually, it has a lot of possibilities. Like, think of it, you have a full static website, but you just want authentication. Well, we have it for you. All of that stuff. Cool thing is, it's fully free. Well, fully free. It has a very generous free tier, and I manage a lot of websites on my Astro Studio. Like I do, I think daily 15 million queries. And it's not because I'm popular. No, it's because I'm really inefficient at writing queries. Yeah, it's really bad. I now enabled caching and it's still like 10 million. But still, it's still all in the free tier. But I know talk is a bit cheap. So why don't we code it live? Well, I'm going to try at least. We'll see if I actually succeed. So Let me try something. All right. You cannot see anything, right? Yes. Let's fix that for you. And let me also make sure then that the stream also works, by the way. So mirror, you guys see the same as I do now, right? Yes, good, thank you. Going to put that back on, optimize for Blackmagic, sure. Can you guys see clearly on that? Yeah, is that big enough? Okay, so first of all, I'm going to start like, yeah, this, because I want a clone project that actually already has some things. Nice, so I'm going to cd into it. Oh yeah, DB place, sounds good. And then VS Code open. Nice. All right, that's probably not big enough. Yes, can you see this? Good enough? Okay. So what I've done here, it's really simple. I'm going, oh yeah, install dependencies, lol. Yes, let's hope Wi-Fi works with us. Okay, so this is just a normal like Astro thing. It's really easy to understand. Like we have a source folder. It has an app in there, which is just a React app that I cloned from somewhere else. Well, Fred actually did. And then there is a couple of components, and there is a couple of pages. The pages have 2 API endpoints. That's all you need to know right now. So once I do npm dev, it will get more clear what I'm actually doing. That should be this. All right. So this is just a blank canvas, and you can place pixels. Nice. But if I reload, all the pixels are gone. There is no state. So what if you actually want to do it with a database? Imagine it being a full database. So what I did, we have like the DB folder here, and it has a config in it. Basically tells you, hey, I need a grid cell table, and it looks like this. It has 3 columns, a value, an X and a Y component. Well, Y value, that makes sense. Then we define the database and export that. Easy. In our scene, I'm going to say, hey, I'm going to see so many rows. It's really an inefficient thing, but that doesn't matter. Like, that's basically what it does. So how do we do this now? Well, I have here in the, by the way, look how easy it looks. Just basically in the body, there's only one app. So I have this click thing. I'm quickly going to scroll down here. So what I want to do is actually insert that click in my database. Really easy. So what I'm going to do, I'm going to uncomment this, db.select. We actually use, how's it called again? Drizzle? Yeah. Grid cell. And, oh, I'm not going to select, I'm going to insert that, sorry. Come on, work with me. I have to import my database, I guess. Yeah. Good. So let's insert a grid cell with values, x, y value, that's correct. And then I just going to remove that. That's it. Now when I place my pixel, you would expect it to work, and it does. But there is one quirk. Where did you see me set up that database? You didn't, because actually the database is an SQLite. Well, it's a fork of SQLite, it's libSQL. That is just totally locally, and I can totally show you that. Like if I do SQLite open database, it will show up, and now you will see there is actually cells inserted. Whoa, that is really cool. No, don't clap for that. And then of course, we still have to read them, because when now I refresh, they're not there. So I'm going to check that. So in the refresh, I'm going to pick my cells here. I'm going to delete that. And let me add it right here. So await db.select from grid cell. And I just return all of them. Let me also import that. Don't break down my room, please. Yes. Astro DB, no, Copilot doesn't work with me today. Oh yeah, and grid cell as well. Nice. Oh, that makes sense. db.select from grid cell, that makes sense. And now it works. We have a fully sustained app. Cool. It's not quite worthy, but I'll take it, I'll take it. The cool thing is, now we have only seen the local variant. So what if we just deploy it? Let's try it. So first of all, I'm going to build it. And there will be a problem. So I build it, and you see it's, oh, directory is not linked. And what is not linked? Well, I didn't link any Astro Studio project, because that makes sense. I want my database to be hosted somewhere. So I'm just going to do npm astro db link. And it will say probably login, but I think I'm already in. Yes, I want to link it. With existing project, no. Create a new project, yes. What's the name? DB, well, call it DB Place London, because I have a couple of those. Yes, where do we want it? Well, we're in Europe, so let's do that. Well, Europe, expensive, well, cool. I'll just shut up. So now, if we actually build it, so let me do it again. Linking to remote database. Okay, it does it. And now we have it built. Cool. So now we can do the deploy. So I'm just going to do Vercel deploy. Set up and deploy. Oh, actually, I forgot one thing. npm astro add Vercel, because I want to actually deploy it on Vercel with the serverless function. Yes, continue. Let's hope that the internet works a little bit with us here. It does all of it for you, by the way. I'm not like doing anything. I'm just doing CLI commands, which is really convenient. So if I now build it, we will have, instead of like the dist folder that you see here, we'll have a .vercel, which actually contains all of the code. That makes sense. Cool. Vercel deploy. Setup, yes, please. Loading scopes. Let's please not deploy it to the Astro scope. Oh, yeah. Close, exactly. What's my name? Well, yeah, let's go with DB Place. Which directory is my code? Yeah, it's here. All right, so it's uploading. That's all I had to do. Do you want to modify? No, fuck no. Deploying, yes. Cool. So that's working. We now should have, let's check in Vercel, if we actually have it. Not the test one, but DB Place. Yeah, we have it here. Okay, cool. It's not going to work, and I'll tell you why in a sec. And please, no, don't make notifications go. All right, we have it. Let me check. Oh, error. Or am I in the wrong one? Oops. Oh, nice, I fucked up. Now the question is where? Build exited. Yes, but why? Good thing I have a backup. I probably did something stupid, and I don't know. Because the build succeeds. Vercel deploy. Oh, it probably will tell me here. Let's quickly, no logs. Main. Oh, I know what it might be. Let's quickly check. Yeah, there is no login because you need to log in for AstroDB to work. So what I'm going to do is add an environmental variable. How do you call it? Environment variables? That thing. .env, yes. So let's go to my project, and you see DB Place London. It's here. But there is actually no tables yet because I didn't push that. Good thing I see that now. So I'm going to quickly do that. npm astrodb push. That will basically push. Well, what the fuck is happening? Yes. Basically, this will push your local schema and stuff to the cloud. Makes sense. So now when I go to database, whenever it did it, now we'll see grid cell. It's there, but there is nothing in it. That makes sense because we didn't put anything in it. Good. I'm going to make a new token, not webhook, for Vercel. Let's generate that. Perfect. And then in the DB Place project, let's set it up as an actual environment variable, which is called Astro Studio App token. I actually don't know if that's correct. Good thing we have docs. Oh yeah, I'm totally serious. I do this all the time. Deploy with a studio connection, that's what I need. Yeah, Astro Studio App token, I was almost right. Or I was right, don't remember. Yes, I was right, nice. Let's deploy that. Let's see if it now automatically detects that and rebuilds. It should. Exciting, all watching the build process happen. I really hope it works now, because then I have a cool thing. Installing, good, good. Build, remote, yes, done. Okay, cool. Woo. Thank you, Vercel. I mean, it wasn't me. All right, so if we now have just a blank thing, it works. Authentication, yeah, let me turn that off. So you all can join me, that would be fun, right? I'm sure you will not draw any penises, right? I hope. Yes, enable. Good. So let me copy that link. If I now place one, it's not there, it's there. And if we go into my database, it's there. Simple. So why don't you all join me? Let's draw something together. Scan it, scan it, scan it. Yes, I'll leave it up for a while. Is that big enough? Am I not in the way? And then start drawing pixels. It's coming back, it's coming back. Give me a minute. Ooh, y'all going fast. Oh, and this is really inefficient code, by the way. Like, it's supposed to be like very janky. Nice. Well, that was my talk, basically. Nice, I heard. I'll leave it going. I'll put my last thing on. So, base plan is free. Try it out. It's really cool. It has amazing stuff in it. You can see it. Right, nice. So if you want to stay updated, we have, of course, astro.build, which is our website. We're all over like Twitter and stuff as well. Follow us there or follow me. Like, I'm also really cool. We have astro.build/chat, which is our Discord server, where that's the best place to go for support and anything else. And we have a newsletter now as well. Thank you. Woo! I think I was the last one, right? Nice. Let's go have beers then. Hello.